Hey guys, welcome to another live stream, and today we're gonna be trying to test these actuators, and we finally got our hands on the PC over here. So we had to wait a couple of days for this PC, and we finally got our hands on this. We just installed Ubuntu in there. We were setting up a few different libraries and stuff, and the display for the Ubuntu is not the best right now, but you can see the screen over there, and I'm gonna try and adjust it a bit so it's more visible what we're trying to do. But we also need this bottom camera over here on the table to show the motor moving, and I think we have everything except two bearings. We have everything we need to put together the upper body of the robot. I'll let this train pass by real quick, and then I'm gonna continue with my talk. Alright, first time boot up, we're gonna make it yes. For some reason the PC has become slow. Yeah, it happens. Like, I mean, it's putting a lot of some of the cube ID stuff might be still be getting stored in the cache or something. So after that, it will like it takes a while for it to. The driver is connected. I'll try running it. Yep. Let's try running it. Debug mode. No SG link detected. No ST link detected. Alright. So we will have to manually install that. Let me check. Intel and UC PC. Driver. I am getting error. I am gonna edit the call and I'm gonna make it for like Ubuntu. Let's go for 3 hours. Stream it till assembly. Start call. Make sure the ST-Link USB cable is securely connected to the Intel NUCs. Like, that's the first thing. It seems to be connected. Yeah, I mean, it's probably a driver's issue or a software issue. Okay. Check ground clock pins. I mean, we can't do that. Like, we can't open the USB drive there. Let's see. But anyways, we are setting up the software side on the Ubuntu right now, and we have this motor in the frame right now, and this is the first one we're gonna try to run today using the software. And once that is done, I think the process is pretty straightforward for the rest of them, and we're a bit optimistic about the goal. So hopefully today, by the end of this live stream, we're gonna have the upper part of the robot's body assembled. It seems like it's a permission issue. It seems like it's a permission issue. I'll just... The reason is because it is able to... We have a chat rate of 1. I mean, I was just setting some goals in there regarding the super chat and... Hardware is connected and visible. So next update... Really? Do we want to do that? Yeah, I mean... Okay, it's like it's creating an ST... Because ST-Link exists, it is able to find it. You can see over here. Unlike the Mac OS, we are able to find ST-Link. However, it's a permissions issue. So let's just create this file, but we want to remember where it is. /etc/udev. I mean, before that, you might wanna like... Let me just grab a screenshot so we remember this. You might wanna start like this with the terminal with the sudo permission before that. So maybe if it's a permission issue, you might wanna do that. You know what? Some people did mention that running this program with sudo fixed the issue. So yeah, I think because right now it doesn't have all the privileges of a root user, and but how do we run it using the window as sudo? Just close this one. Just close this one. And yeah. Check from here. Let's try this. Let's try this. Control and O. We did not install the latest version of the STM IDE, and that's because we were facing some issues with the BLDC motor driver, some softwares regarding the BLDC motor. I made a video about that and I've uploaded that on my channel as well, and some of the latest versions, they were causing a lot of issues. So right now we are not on the latest version of the STM32Cube IDE software, and I doubt the issue is because of that. I'm pretty sure if we update to the latest version, the issue is still gonna be there. I generally like, it's always a good idea not to be at the latest version because there are so many issues that still need fixing or that are not addressed in the latest versions.
I hope this fixes the thing.
Yep, I think if it's not there, it's probably gonna fix it. So it definitely downloaded something new, right?
It did download something new.
Yeah, I think so.
Oh, so like it is able to.
So I think you once you've downloaded it, I think we will have to restart STM. Yeah, could not determine the GDB version using. Okay, so it's
no way that is showing the same.
It's the exact same issue.
Yeah. Anyways, let's exit and restart the PC at least once, and if we're again facing the same issue, then there's no way around. We would need to fix this. Power restart.
I really want there to be a way to share this screen, but we don't have any other option right now.
Yeah, at the moment.
When it gets reloaded, we also want to double check if we are on the right Ubuntu version, which we probably are. But the way to fix this issue on this Ubuntu version, it should not be that difficult compared to the 24 one.
I hope so. I hope so that we're able to simply
do a wget. Yeah, I think that's why they selected this version, because it should be straightforward in case of this version.
Let's first of all check the Ubuntu version.
Scroll all the way down, about
Ubuntu 22.04.
Yep, so we're on the right one.
This is correct.
And let me grab this as well, and let me try and plug in the power for the controller as well. So black should be the ground and the red one should be this.
Build the project. 0 errors, 0 warnings. It's just when we run this code we face this issue. Okay, so we want to install this ARM none EABI GDB specifically for Ubuntu 22.04.
Yeah. I think looking it up on Google is
best idea.
Yeah, best idea. Yeah. GPT would like mess it up so bad because of the different versions.
It'll actually it'll be easier for us to look it up and solve this ourselves instead of using GPT. Could not determine GDP version. GDP version Ubuntu 22.04.
Yeah, jammy jellyfish.
Also this ARM none EA error. Yeah, Ubuntu 22.04. Let's see.
Okay, so he's just mentioned the issue.
Yeah.
Download and extract source code from Python
3.6. That's like so old. I think the latest is Python 3.12 or 13.
Yeah.
Not sure.
I mean, like, yeah, 3.6 is really old.
By the way, do we even have Python installed in here?
Which 3.10?
3.10 is actually my favorite distribution of Python. So this is the most ideal situation that I am in. Oh, we don't have pip. Okay. In my case, my GDP required Python 3.8. The command set Python path looked the following way. So it's a path issue.
Yep, so it's not an issue of this not being available in the operating system. It's just like
let's see. We'll first of all type this and we'll see if it even exists in our system or not. If it's
I mean it depends on the Python version you're using to call this, like the user mentioned. It's done over there. You can enter the command. Yep, so yeah,
command not Ubuntu 22, yeah. GDP open COD.
so does it come like pre as a package with the
But
version of Python you installed?
Python 3.8.
Yeah.
Changing GDP multi-arch was the solution for me.
I think we can just go with changing our Python version.
But no. Just changing the Python version does not mean that all of the package, because this Ubuntu came pre-installed with all of the
yeah.
That's like a whole.
It's gonna mess up a lot of other things as well. Yeah.
Ubuntu 22 comes with Python, but ARM needs Python 3.8. Changing GDP. Your answer could be, well,
try and now put it in GPT as well. So we have a bit of context on the issue. Now I think we can go to GPT as well.
it's just a stupid packages conflict. I will feed these to GPT and see if it's able to come up with something.
I think first you should
Do we not have it open? Chat or
this is not particularly like our issue. You should take start the chat with our issue. This is like a true
issue is that we are trying to run STM32 for Berkeley Humanoid Light motor driver calibration, but we hit an issue, and the issue is of course this. My Python is 3.10 and it is Ubuntu 22.04 LTS.
it's like you need to upgrade all the new packages as well, like the just a second. So all the new packages you located, when you look for them, this will install all of them.
Yeah, so like there's it's also telling me to install 3.8, but that's going to be a huge compatibility issue.
Have have they mentioned any error regarding it, or I think people on their GitHub might be discussing this issue.
It could be.
Let me have a look. Yeah. Just a second. Nope. So the issues they're discussing, they're totally different issues. EA I think we can just turn the music a bit up for today's live stream because we are a bit focused on.
No, it's just it's cool. Whatever the sound.
I mean, I've raised it at this level.
Okay. Check over here. Hassan, check over here. So this guy is facing the exact same issue. He's trying to use STM32.
Yeah.
And on Ubuntu 22.04 LTS.
Yeah.
Same issue, GDP version, ARM, none this.
Okay.
He tried for a long time and finally he stumbled upon this life-saving blog, and with the help of this guide he was finally able to resolve the
what
issue.
does it like? What does it say?
He has also created this PDF for helping. Let me see.
Yeah, it's the exact same issue, right?
Yeah. So like it's the exact same. So we can maybe follow.
Yeah,
these steps.
just follow it. Just let it update everything. So.
Alright.
Yeah,
First of all, I'll try this. Still not found. Alright, let's try fixing it via this. There's no straightforward way to determine the latest version of the toolchain via command line. So download web page and extract the latest version of the toolchain as follows. Okay, let's see.
It's done.
No. That's not the one. I just installed curl and now I will run this. Oh. Okay. Download archive file from the official website, but ARM toolchair version. Okay. Create a new directory to store the tool. Extract the files. Okay. Add opt gcc arm directory to path environment variable, and to make changes to which Python are they using in the path? Okay, whatever our default Python version is. To make changes to, and then version. I hope this resolves the issue. This seems promising.
I hope so.
This does seem promising. I'll be back in just a second.
If we're like using a different system, like a Raspberry Pi, oh, it's done. Like a Raspberry Pi or some other PC, will have to SSH into that system, get the live feed from the desktop and share that. Let it do its thing.
Did I press? Oh, okay.
Yep, it's done. It's done.
So sudo tar, then export the path. To make changes,
We'll have to log out and yeah.
Let's run this one. Oh, why did the color change?
Because now you're using a, like, now it's not a root or the default user.
There is one existing now. Strange.
I think it's a good idea to
Remove
log out.
unnecessary files. Let's just keep it for now. Yeah, let's just try logging out and logging in once again.
It's a good read. This blog. Are you sure you can find it again? Just bookmark it. Just bookmark it here. Bookmarks.
Current tab.
Current tabs.
Let's try restarting and see if we're able to fix this. In the meantime, we can maybe discuss 3D printing ideas and 3D printing as a business and industry.
I think the demand for, in terms of the industry we are looking in right now, which is the cosplay industry, I think it's evergreen.
Yeah.
I don't think there's ever gonna be a time in the foreseeable future where the demand for it will be less. And with the marketplaces we're doing, everyone after like 2 or 3 years in the game recommends having your own website and everything. But to start off, whatever marketplaces you do tend to use in the start, they are all like 2-3 year grind.
Yeah.
They're all like slow moving whales.
Markets or
Just the platforms like Etsy, for example. It's
yeah.
you do have to spend multiple years on there before you can
Really?
before you can you have a solid client base that you can take somewhere else, like for example your own website, wherever.
No, so there was one guy that we saw who had pretty decent results within the first year.
I mean,
Remember?
it's a give or take, like
he was not entirely profitable, so to speak, but he said that I'm gonna carry this in the second year.
Yeah, I think it's gonna become more and more clear once we start. But it's most of the people I've seen, they don't have really good results in the first year. But it's one of those things.
Go.
Wow! So it has started to work now.
Yep.
And let's
Plug it in and let's just follow steps one by one now.
Alright guys, so we have fixed the S-T-Link issue, and the other issue we were facing, we're gonna see if we can make a video on this. We're probably gonna right now we are trying to calibrate these as fast as we can, and then we're gonna put together the body of the robot.
Okay, let me open up Humanoid Light docs. Hardware and flashing the motor control. Alright, so let's start doing this. So first of all, we have to do first time boot up to 1 and run it once. Okay.
Yep. Just put them in parallel, side by side.
Yeah.
So you can follow these steps.
Alright. Core, ink, and then this is the one that we have. Alright, so first of all, we have to turn this to 1 and flash it. So let's do it once. The motors are connected.
Yep. The power is connected.
Just run.
And
this.
everything.
Okay. Alright, exit. Now, after flashing with the initial configuration, power cycle the board by unplug and plug in again the USB cable, then change this flag back to 0.
And I think we will have to. I will have to disconnect it.
No, not from there.
I think
oh yeah, from both.
yeah, from both of these.
So yeah, just remove it and remove this. Now I will plug it in back again.
So I think we
and with the first time boot up to 0.
I think it would be a good idea to bring this in the camera as well. Let me try and place it somewhere where it's easy to see.
So this is like the first time boot up.
We have not attached the encoder to the motor yet, and I don't think we need to do that.
Now we need to power cycle. We've already done that. By the way, he doesn't have it attached with the.
Yeah, I mean we can remove it. No worries.
Change this back to 0. Load ID this 0, this 0, this 0, and this 0.
Okay, up till the. Did he turn the safety watchdog enable 0? No. So up till load calibration from flash.
Okay. Zero.
Load config from flash and load calibration from flash.
0, and then I presume we have the safety watchdog enabled. Project, build the project. Okay, there are some warnings. If you're using a different CAN ID, set it here. Now that's just something we would need to maybe spend a little bit of our time on. Device CAN ID. We need to have the CAN attached for this one, I think. This time. Is it wired? The CAN wired?
No, it's not wired.
Let's just quickly attach the wires.
Yeah, we can.
Let's just quickly solder them. This is a MC612 actuator, right?
Yeah.
Yep. Take off the connections. So I'll take it off from here. Let's just solder, and
let's just move this out of the way for now, somewhere around here, and let's change the mode to ambient so we can. Yep, now it's ambient, so we can speak from any direction. It's also gonna pick up way more voice from the room, but I don't think that's an issue.
Yeah, so today our goal is to at least have the upper body assembled by the end of this live stream. So whatever issue we face, we'll just try to sprint through that. So if the CAN connections are still to be soldered, we will simply just solder right then and there and attach the CAN connections and calibrate the actuator. We want to finish all of the actuators one by one, all of the ones that we need. If they need wiring, we'll do that. If they need any software flashing or calibration, we'll do that. We want to make sure that the upper body actuators are ready for assembly, so that way we can just start moving towards assembly side after this calibration.
You know, I think they have also attached the encoder over here on top of this magnet. So I think we will also
for calibration that's important for calibration.
I think most probably we'll have to do that as well. But I think we can detach these CAN wires from this not this one.
This one.
Which one was it?
It's this one.
Just grab that one, and we're gonna desolder it from there, and we're gonna put it over here with the wires attached and everything. So all the bells and whistles, everything ready. Just be careful with it. I don't think it's that one. I think it's a different one you're picking.
So both of these have the CAN wires.
but only one of them has the can attached, the USB to can.
Let me see if it's okay. Not even this one, it's this one.
Yep.
But this is a 5010.
Yep. No need to worry on that side. We're just gonna remove these 3 connections from here, and then we're just gonna solder these wires on here.
Okay.
Yeah, just I want you to pull on these slightly, and if the solder is hot enough, which it is, I'm just gonna.
I don't think the solder is hot enough just yet.
This is it.
So once again,
put it back there.
okay, so once again, just to summarize our progress so far, we have built all of the actuators. They are lying down on the table just beside us. The wiring also is almost done. It's roughly 90% of all the wiring is done. We were waiting for this PC to arrive, which you can see over here. Now that we have this, we have installed the STM32Cube ID on this, and we are just flashing all of the actuators to calibrate the BLDC motors. With the calibration done, I think the next stage is just the assembly. With this, finally we will be ready to assemble the upper body of the robot, which we aim to and we're hoping to start doing today. So our goal once again with today's live stream is to have the upper part of the humanoid robot assembled as much as we can. So we're just gonna continue working for a couple of hours. Let's see how much we're able to do today. For the people tuning in, are you guys working on any interesting projects in software or hardware domain or 3D printing? Any interesting personal projects, hobby projects that you're building, or any professional projects? If you're working for any clients, we would love to know about them. We would love to have a discussion regarding those projects.
Yeah, I just soldered them from my memory, but I think we'll have to double check, of course, if the connections are okay or not. And we also need the multimeter. If you can pass that to me.
Check on this. I'll open up the connections from the website.
Yeah, I'm gonna bring the camera a little downward so we are able to see what's going on over here. And I'm just gonna double check the connections are right.
Building the actuator. Alright, here we have the connections.
Just a second. I think they're good, and just to be sure, it's the ground, the can L and the can H in this order. Yep, I think they're good to go, and we also need to fasten the encoder with the motor over here. So let's quickly do that as well. I'm gonna turn off the soldering iron. Meanwhile, you can just grab an M2 screw. By the way, we got a lot of new M2 screws and washers today. I think it's gonna be it's the one with the like smallest screws. It's gonna be in there somewhere, most probably.
Over here, possibly. No, these ones are a bit longer.
Yeah, this I think this is the one. Yeah, this is the one.
Maybe you can open up and try.
Or maybe we have a bunch of new ones. We can just unbox them. Let me turn off soldering iron. So
here are the new ones. If you want. Yeah, these are the ones I think.
Yeah.
So we also did bring some parts today from a hardware store. Some parts which are missing for the robot. We'll be unboxing these and using these. Yeah, here are the washers. Might also want to use them.
we do need them as well. But yeah, just quickly we're gonna unbox these as well. So I'm only gonna use two to fasten them.
Okay.
We're gonna grab one. I'm gonna need you to grab
A
screwdriver.
screwdriver and a small one at that.
I mean, I think even a big one will do, or just the yeah, this one will do. This one will do just fine.
And just use this one.
So there is an issue with the alignment of these 4 screws with the hex inserts.
Yeah.
Sorry, the brass inserts, and you have to kind of hack it a bit to get it in its position. It's possible, but the CAD model is off. As you can see, these screws don't align perfectly with the holes, but you can get it on there. It's just not perfect, but it's enough for us to start testing it now.
Can you verify the CAN connections from this diagram?
Yeah, let me double check. We have the ground. Can you grab the nail cutter from here? I've gotten it. I'm gonna remove any excess wiring so we don't get any short circuit or something along those lines. We've gotten rid of it. Yeah, so I think the connections are good.
Right.
The connections are good. I think we can these ones will probably be good. Let me double check. So we have the ground here, we have the CAN L, and we have the CAN H. Yep, so these are good. So I'm gonna grab a USB-C to USB cable for the PC, and we can just plug it back in. We have the encoder wired up and ready as well.
Alright. There's one more thing I want to take a look at before we jump into the calibration. Onboard computer, software development environment. Initialize the CAN transport. Okay. Alright. Test connections with IMU, test connection with joystick, Python code. Alright, before that, software development environment, cursor.
Yep, I think you can plug it in there from here.
Let's plug both of these in.
Yeah, and this is the wire for this.
Yeah.
And let's make sure this is not getting short. I'm gonna hold it in place, and
I think this time around you can try to
power it.
Power it up. Yep. But let's watch this video.
Okay.
So we want to select this right motor from here. In our case, I think this
is a M6 E12.
Just to confirm.
Yeah, MAD components M6.
M6 150 kV. Yes, it's 150 kV M6012 actuator.
Yeah, pass me the battery from there.
Okay.
I'm gonna power it up.
Can you check from there? Is it really powered? It seems like it's not in the video, but let's
Yeah, I mean,
power it up.
if the motor is running, it's obviously gonna be powered up. And this video, if the motor is powered. Okay, I have attached the power connections.
Set the connection. Click run for the third time. I mean, it seems like it's the second time for us, but okay. Well, okay.
I mean, no, it's the third time, of course.
So first time it was with the first time boot.
Yeah,
set to one.
then we had to set a bunch of load from flash 0, and then now we're setting the motor right, and
Project, build this project this time and click run once again. Alright,
and it's
done.
blinking, but it's
Yeah, that it's blinking for them as well.
I mean, not this one, not this one. Yeah, now it's blinking for them.
Notice
as well.
the LEDs are blinking. They're also saying it.
Yep.
And okay,
set those fields back to 1.
okay, so 3 fields, load ID from flash and the bottom 2.
Okay, so there are quite a few steps to even calibrating one of them.
Yeah, so load ID from flash.
1, config and calibration. And let's check the video for before.
They just click run out right after that.
Like not even build it.
Set these fields back to 1 and run.
Run, and let's see what happens on the other end. I want to see what happens with the motor. So Ali, they haven't even attached their USB to CAN yet.
Yeah.
So we don't even need to.
Alright, it's okay. We can just keep it attached. We'll click on run. Oh, save, of course.
Yep.
Save. Now you can proceed to run the calibration part. Okay. Connect the CAN bus of the actuator to the computer through the USB CAN adapter.
Okay, and then power on the actuator.
Before running the Python script, you need to run this script to start the socket CAN transport on the computer.
Okay, so yeah, this is what we needed this PC for basically.
Yeah. Let's start doing this. There is something we want to do first of all, which is onboard computer section.
I mean, I'm gonna try to get the PC in there as well, so let me try to adjust the camera meanwhile, so you guys have an idea on what is being worked on.
Be careful with the screen.
Okay. I mean, yeah, this is the best we can do. Sorry guys. Let's bring it a bit towards this side and let's push this a bit inward like this.
So some of the subdirectories are not cloned. How?
Okay, so it's the same issue like before.
No, I haven't really cloned it. I just want to make sure that
Yeah.
it gives a
Yep, makes sense. Yeah.
Alright, let's try this command.
Yeah, with how fast we're trying to sprint through this, I don't think we'll be able to make a video on it even. Yeah, I think we can do it if we rewatch our own live streams and figure out all the errors we've had to solve to get this thing to work.
Let me just clone this. What?
You just pasted the link, right? Git clone first.
Okay. Let me just quickly check from here if this cloned correctly or not. Downloads, Berkeley Humanoid Light, source,
It's not gonna be cloned.
light low level.
Of course, it includes sub modules. You'll have to clone those as well. Yeah, just remove it.
How did we do it the last time?
I think it was a command. No, yeah, we used a
I
command.
tried this, but this one is not working.
Yeah, I think you can try using it again. Git clone recursive sub modules one.
Let's first of all install LFS. Paste LFS install. Okay. Now let's clone into this and cd into this. CD Berkeley Humanoid Light, and then git LFS full.
I don't think that's how it's supposed to work.
Still not. There. Git branch. There's no yet.
No, GPT is assuming that you pulled everything. I mean, it's just like going down the wrong alleyway of thought. Yeah, you probably wanna do this. Just remove everything altogether and rerun this.
Okay.
Try it again.
Wait a minute.
Yep. And next, yeah, run this.
Failed to clone. See.
Yep. Now give it to.
Okay. Can try this.
Let me try and look for some stuff on Google that might help us.
Yeah, I think it's fixed. It's fixed.
It's fixed.
Now that that is out of the way, we needed to install these basic dependencies. I'll just do this.
Thank you for dropping that like on the video. We are currently working on calibrating this motor right now, and once we are done with this calibration, we're gonna proceed to assembling the upper part of the robot's body. So this PC just arrived today, and I think this was the main issue that was keeping us from assembling the body. Oh, Reg came in the chat. Hello guys, I was not there the last two videos, too busy with the family. All good, all good. It's good to know you're spending time with your family. Hope everything is good over there. Hope weather in Canada is nice these days. It's awfully cold here in Tokyo, and it's gonna be raining for the rest of the week. It's been raining cats and dogs here. So yeah, and during the last two videos we did very little soldering and very little actuator assembly, and we did not had this PC. It just arrived in today, so we were waiting on this to move forward with the calibration of the actuators, and that's where we're at right now. Yeah, I really wish we were able to share the screen of Ubuntu as well, but we just got this PC like a few, I'd say an hour ago, and we installed Ubuntu on there, and we hooked up an HDMI port, and we just started this live stream. But if we had more time, I would definitely have added that Ubuntu screen onto this live stream as well, but we just want to get to the assembly part as soon as possible.
Okay, verify the installation. Once installed, verify that UV is accessible. With UV, okay, it is. Let's run the command once again.
By the way, if any of you guys want to see the screen of the Ubuntu desktop only, I might be able to make a camera angle for that, but it will take some time. I'll probably put up like a waiting load screen or something like that meanwhile, and I might be able to play around with the camera setup and focus it only on the screen. Reg just asked why you choose this PC. Why not buy a Jetson Nano Super? More powerful for mostly the same price, and it got AI in it. So Reg, the thing with this PC is we gave a bill of materials to our client, our partner who is working on this project with us, and we are handling all the hardware assembly and development. And because the deadline is really brief, we asked them to buy whatever the stock material was. We had no room to explore different options as much during this project. If we were flexible in the timeline, if we had all the freedom to explore different options, which we would definitely have done, like I would have loved to modify some parts of the actuator as well, because the holes are not perfectly aligned for the encoder. But because of the tight deadline, we are just going with the stock materials, and we're trying to assemble this as soon as possible, and we're trying our best to document the entire process as well. Okay, understand.
Yeah, there's also one very primary reason why we went with this specific PC. The software code for Berkeley Humanoid Robot has been made keeping in mind a very specific architecture. So it's Intel, AMD or ARM 64?
Yeah, AMD 64
Yeah,
architecture.
x86 underscore 64 architecture. So Raspberry Pi or Jetson Nano, they have different architectures.
Yeah, I'm not too sure about the Jetson Nano, but we tried with Raspberry Pi,
we tried
and
with Raspberry Pi.
we kept running in
conflicts or issues regarding the system architecture, the paths, the various dependencies. We actually did try with Raspberry Pi, and it was a nightmare. So just to save time, the software they have built for a very specific architecture, it just works well on that architecture. The paths, the environment variables, all of them are standardized according to that architecture. So that's why we proceeded with the purchase of this specific PC.
Yeah, by the way, it's not to say that it is impossible on Raspberry Pi. You can do emulation there, and whatever libraries they have set up for the other architecture, you can edit them, modify them, go through them, but it's gonna be a long process trying to get it working on the Raspberry Pi. And so because of our deadline and timeline, we just went with the stock software, the stock everything. But if we play around with this robot in the future, which we probably will, we will go with the route of Raspberry Pi, because there's just way more support there's gonna be way more support available for that in the future.
Still the same issue. I did install Python can. Still the same issue. A pure Python can. Okay. What is this issue? It seems like you've successfully installed the Python can. Okay, source.
Reg said, I know it's not related. Is that a shredder on top of the keyboard on the left? I'm gonna bring it in, and I'm gonna explain what it is. So we have quite a few projects lying over there on the side. Let me try and grab it. So this thing over here, what we are trying to do with this is, we're gonna this was a module made for a robot that tried to pluck weeds and plants. So this is like a prototype, and our goal with this was to test how much luck we had pulling plants and weeds and some thin tiny bushes from the ground. And we tried this with PLA, we tried this with PETG, we tried this with rubber filament, and we have a bunch of versions of this lying around in the lab. This is just a basic PLA version, and there's a whole assembly that goes with it, with a stepper motor and everything. And the PCB I showed in an earlier live stream, let me see if I can grab it. Yeah, this PCB was made to go with this one. This is just a standard PCB I have made. It works really well with most of the projects in the mechatronic space, like most simple projects just to test stuff out. So this PCB was made for this one. So yeah, it's not a shredder, but I think if we push them together and we try to pass paper through them, it can mess up a paper really well. I don't know about shredding though. I think we can modify the teeth slightly differently and make them a bit larger. I think it will do a good job of shredding that way. That corner over there, it's a graveyard of ideas. So there's a bunch of other interesting stuff lying over there as well that we worked on in the past. This is also a gripper, and this one has a rubber grip on top. So this is PLA, so it's just plastic, and this one is rubber, and it's a really dense rubber, and we printed it at a really high density because of the force that was going to be applied on this gripper. But if you really push it, it squeezes a bit, so it's not like 100% solid, if that makes sense. And we have a vibration motor over here as well. So this is a 12 volt vibration motor, and it vibrates really well. So yeah, this is another thing we were working on.
Let's go. So our first motor is on 9. It's been calibrated correctly.
I mean, isn't it supposed to rotate or do something?
I think now we're getting to that part.
Yep, so we fixed the USB CAN issue as well. I think we'll have to make a video on these small issues that we're facing, but yeah, none of them is significant. Like none of them is a. I was curious because here the community has decided to start recycling. I'm looking for a shredder because cardboard and paper take up a lot of space in the recycling bin. Reg, so this is shredder. The idea of shredder as a business or as a product never crossed my mind until I visited Japan. Here in Japan, at some of the Yodobashi camera stores close by, there are entire sections full of shredders, and they have all shredders in all price ranges, like really cheap ones that you have to rotate with your hand manually, and then they have some really expensive, really high quality shredders that you can feed entire piles of papers in and they do the job. And I don't know, I've never been in a office setting in Japan where I've seen those shredders being used, but it's a really famous product over here, especially in the business spaces as well. I think it has to do a lot with the oh wow, the motor just rotated a bit. Wow, let's go. So the motor is spinning, it's alive. Let's go. It's so cool to finally, after like so many days, see the thing you're working on actually move.
Yeah, we were just missing the PC. Now that the PC is here, we have...
It's the best feeling in the world.
Yeah. The motor will slowly increase the holding torque until the phase current reaches the target value, then rotate counterclockwise And
Yep.
finally rotate back clockwise. Let's check this once again.
Okay, so it was
Counterclockwise.
opposite. Yeah, the rotation was opposite. It's clockwise.
Okay.
No.
Okay,
I
so
think we'll have to flip this over. Now it's counterclockwise.
Okay. That's fine though. So maybe we can attach a small note with this that it's
Yep,
rotation is
yep,
opposite.
yep.
Just grab
I'm
a tape
gonna
and-
grab a masking tape. So going back to that shredder discussion, Reg, I think it has to do with privacy laws here in the country. Like you're not supposed to hold on to information and stuff like that. And because Japanese people, they do a lot of documentation in every department, in every company, everywhere. They do a lot of documentation, and a lot of time they have to throw those papers away. And I think it's some sort of policy here to not throw papers just as they are. I think it's some sort of policy here to shred them or make the information on those paper inaccessible or something like that. So shredders are big time famous over here in Japan. So yeah, what's the next step then?
Just
I think
keep holding it just for 1 second. I'll try one more code.
Yep, and I think we
This is a pretty
no, it's vibrating, but it's not doing anything.
Come on, bro, do anything.
No, but it's vibrating. It's supposed.
Is it? All right. It was supposed to do this.
What was it supposed to do? No, I think it tried to do something, but it's not doing this. Reg says, "Thank you." You're welcome, Reg.
Okay, so for the calibration, it will first move. Yeah, in their case, it's anti-clockwise,
Okay.
and then clockwise, and so like our calibration is perfect.
Okay.
Now, there's a few things we need to watch over here.
Uh-huh.
First, it's motor number 9. So we will very soon need to.
Yeah, we can. I have this masking tape over here, and we're gonna start labeling these motors.
There's one more thing. See here, if the rotation direction is flipped, you can do one of the following. Swap any two of the 3 motor phase wires, which we're gonna do.
Yep.
Any 2 of these we will swap.
We are gonna swap the extremes because
Okay,
yeah,
so
that
just put here opposite, and this one is done. We can just push it aside.
no. The what about the next code? Wasn't that supposed to run perfectly?
Which code?
Yeah, the one that made this motor vibrate, but it didn't do anything. We'll have to check that one as well. And we will have to double check the wiring connections for those motors as well. Just to make sure they're 24 gauge and not 20 gauge. If we just waited like a day for receiving the 24 gauge wires, it would have been much better. But anyways, we're gonna have to make do with the wires we have right now. So I am gonna write this over here. So the direction. So the direction for this one is wrong. And next up, if we are gonna give it a name or a label, because this is probably gonna be the motor for the shoulder, right?
Yep. This is the shoulder motor. Okay, grab this motor. All the connections are attached.
You can try grabbing it. It's just trying to do something, and the velocity is 0 as well, as you can see. Why is the velocity 0? And the position is also staying the same.
What was this?
Rate limiter is late by 1 millisecond. Yeah, so the velocity in our case is 0. I don't think if it's because of not enough power or maybe some setting.
I mean, the power should be okay because we just tested the calibration code.
Can you try? Can you run that again?
Yeah.
Can you run that again?
Yeah, this is the one.
Yeah, it's rotating now.
This is calibration code.
Okay, so this is the calibration code.
I think it's okay to have it till the calibration part. This is some issue which we will need to look into. So I think we can start assembling with the calibration. Start with a small kp, kd and torque limit value to gain confidence on how the actuator will behave.
Yep, so I mean you can start, you can play around with those values in the code, I think.
This is the one, right? And the can ID is 1.
Oh, it tried to move again, like.
Let's keep it running for a while.
But the position is not changing, and the encoder is really accurate, like down to the third digit.
Yeah.
Even if I move the motor slightly, it changes its value like this by this much. It's crazy how accurate it is.
Yeah, so let's just close this one for now. We want to look into the next steps as well. So this was the calibration. Building the robot is just disassembling and assembling with the aluminum profile.
Let's not do that right now.
These are the connections we need to make. But I want to take a look at their diagram. Remember the CAN diagram? By the way, there's also some issue. Sometimes there's issue with the wires. Interference of voltage with the CAN wires.
I mean,
we want to rotate these properly, whatnot.
I don't think that's the biggest issue. But if we fail on all other fronts, I think we're gonna try that. So I think what we can do to try to figure out if you can. What was the code you were running to rotate the motor in one direction?
This one.
PT and ask.
This one.
Yeah, I think now we can run this program. Yeah, so yeah, the motor vibrates, but the velocity it stays 0.
First tell it the calibration is successful. I'll write it.
So there's one tiny step remaining, and after that we're just gonna calibrate the rest of the motors, and we're gonna start assembling the upper part of the robot's body. So
their video, it rotates.
Hopefully by the end of today's live stream we will have the upper part of the robot's body ready, and I will upload a picture of the assembled upper part of the robot's body today after the live stream.
I mean, this could be an issue.
Insufficient power. Yep, I also think that's the issue.
I think for now we because the calibration is successful, we should move on.
Just let me try one. Just disconnecting and connecting it again once. Just to be. Just get it ready. The command you're gonna run, just get it ready. But this is most probably the issue. Yeah.
Okay.
Yep. Run it. Yep. So it moves just for a split second, and then it just kind of vibrates in its position.
I think it's a power issue because once again the calibration is successful. This is a
Can we,
calibration
like, the command you are running,
calibration
can
code.
we? Yep, the
Yeah, so
calibration
there
command
does
runs.
not seem to be any issue with the setup.
Yep, I think it's most definite. But this battery is powerful enough, though, man. Can we control the speed of the motor in the latest code we're trying to run? Is there a way to
So
add
like this is the
Berkeley
command.
Humanoid
This
Level
is
scripts motor move actuator.py? So if we can go in there and we can try,
like
and
why would we want to go in on such a different route?
because
I think
the power is
let's calibrate the motors one by one based upon the arm because
okay.
we do not know yet how we're gonna label the CAN connections.
Yeah.
There's supposed to be some structure to it. We do not know that yet. So let's
Okay,
first of
okay.
all-
Let's first figure that out. Okay. So yeah, let's start by labeling this one, and then I think it's gonna take like an hour. But let's just sprint through
yeah,
changing all of those
we want to
stupid
at least
connections.
have the upper body connected and
Yeah,
ready.
I think all those motor controllers and encoders there with the good wiring. I think we can move forward with those first.
Okay, all right. So like this is one shoulder. Let's take the other shoulder.
Yep.
Now.
So while you are doing that, I'm gonna no, we need these. So if you've got any of these prepared, I think I'm gonna put together these meanwhile,
Yeah.
and then I'm gonna insert the right screws here. So we have.
These are not the ones.
So we need
These are
the
long
other
ones.
ones.
Yeah, we need the small ones.
And it's just one layer of
Yeah,
tape.
just one layer of tape, and we
Okay.
can then put it inside and test if this is okay.
Okay. So we have started to work in parallel now, and the goal is to put everything together. And I'm really excited. I really hope we could have gotten we had access to this PC over the weekend. We would have made so much more progress, but it is what it is.
After building the mechanical structure, connect the electrical components following this wiring diagram.
Yep, so it's like a long sprint. We will have to make the power connections with this battery for
So suppose we are
through the circuit breaker. We'll have to pass all of the wires to all of these.
consider this scenario. So this is one shoulder,
Yeah.
and we have attached it with USB CAN 1 ID, right?
Yeah.
Now we're building the other side shoulder.
Yeah.
Are we supposed to connect it with the same actuator or a separate one? That's why I was saying we have to put these separately. All of the actuators of one arm will be using this.
Yep. Yeah. That's how it seems.
Yeah. There was a diagram here as well, which I want to take a look at. I'm not able to find it.
You might want to go in their Discord and see if anything comes up regarding the CAN cable connections, because yes, if you scroll a bit up over here, here, so it's like two other motors. So simply from this one to the other. So I think we. So, I think they're supposed to run parallel from here out of this one to the other
Yep.
motors.
Here it is. Now we need to load the correct actuator parameters into the flash. The fields that need to be configured is also in this header file. First, configure the CAN ID according to the joint ID mapping. And here we have the joint ID mapping.
Okay, so it's a bit of
This
work.
is really important. This is really important.
Oh boy, I made a mistake here. I'm gonna have to pull it out. We were supposed to put it in here, and it seems good.
Yep, at this point I will need to open up the Discord.
And yeah, where's the new stuff we got today? I need the M3X50 screw, so we were also missing this, which we got today. So I think assembling the actuators has been like we have uploaded video tutorials on it as well, but we've just done it so many times on this live stream
Someone has built this. This is really helpful.
Yep.
Joint ID mapping.
Yep.
It has all of the CAN IDs which we need to upload.
Yeah, we can use this in our videos and give him a shout out because it's really helpful. Yeah. So this one is in there. If you're ever building this robot in the future, it's so satisfying when the final one, these last screws, they go in. It's always so satisfying.
Alright, we will need to do a few things. Okay. So like first of all, we will need to reflash this again. That's the first thing.
Okay.
Secondly, we need to clean that table a little bit and put right arm, left arm, right leg, left leg separately. Right now only right arm and left arm.
Okay.
Let me make some space over there.
Yep, you can do that. I'm just preparing the 5010, the 5010 and the 6012 actuators for the.
Also, I'm gonna visit a local 7-Eleven to grab some food. Do you wanna grab anything?
Yeah. I one onigiri and one of those tuna and egg sandwiches.
Okay.
I think tonight's gonna be a very hopeful night. We will have an assembly by the end of tonight. Yep. Because we are already very, very, very close, almost to the assembly stage. There will be at least a little bit of assembly by the end of tonight's live stream. So yeah, let's keep going. I'll make some space here. Man, and I really wish we had multiple cameras set up and we could like record everything. Yep, it would have been so helpful, especially for the videos we were gonna make later on as well. But I think we'll have to record a bunch of the videos with the other cameras we have, the DSLR and the other iPhone, and we'll see how much footage we have for the summarized videos we're gonna be making later on. Where's the dinosaur? Do we have the dinosaur in here? Or
No,
I'll
most
have to
likely no.
bring it. Because I'm gonna go and bring in the dinosaur because we have so many of these to put together.
Okay. Yeah, just bring it, then I will leave for 7 minutes.
Yeah.
Alright guys, so we're at a stage where calibration is successful, and at this point we have to do something which I will show you in the camera over here. We have in total 4 CAN to USB connectors, and we want to label them like this. So this is a very useful diagram which someone in the Discord server shared in the community in the Discord server, and we will be using this as a guidance, as a guideline to separate out the actuators for the left arm, the right arm, and the legs. Right now we're only focused on the upper body first of all, so we want to first of all calibrate all of these. But the important thing in calibration is that we want to set the correct CAN IDs for the CAN USB connections. For that we will be referring to this diagram, and yeah, let's just start calibrating these one by one. I think it won't take us long, maybe, I don't know, 2 hours, 1.5 or 2 hours maximum, but we'll have both arms set up, and after that we'll just start assembling the upper body. So yeah, looking forward to it. We'll be working on this.
Just before you leave for the company, let me know where the remaining hex stands. The the 10 with the 10 length where the rest of them are. So I'm gonna be putting together these meanwhile.
Don't put them together. No, why are you putting them together? Just keep them opened and we'll put them together for assembly.
Okay.
Yeah, because there's no
But
need for them to be.
you know we do have to do a lot of soldering as well. These wires, they need to go to the motor controllers.
So
We have to attach magnets over here.
But for that you do not need the actuators.
Yeah, I know. But we need to do all the rest of the stuff before putting them together.
Yeah, it's a better idea to keep them open and then calibrate them. I don't know where these are.
So
Yeah.
this is totally wrong length.
Yeah, I don't know where exactly these
The
are.
size.
We'll need to look for them.
Okay, I'll look for them.
Yeah, I'll be back.
I'm gonna write a BRB and place it over here, and I'm gonna look for them in the lab then. So guys, we have these hex inserts somewhere in our lab, but we're gonna have to look for them, and we need these for the putting together the actuators. And I'm pretty confident we have quite a few of them lying around, and they're enough to put together the upper part of the robot's body, but we just need to find them. And then we need to do a little bit of soldering, not too much. And these actuators, they don't have a magnet in there, so we're gonna have to use a hot glue gun to put the magnets for the encoders in there as well. And once we have those in there, we can simply attach the encoders on top of on top here using the small M2 screws we have. And for all of these actuators, we did a live stream where we prepared everything for this stage of the robot building, and they're gonna be these motor controllers and encoders. So I have a bunch of them prepared. I have them ready for this stage, and they are using the correct 24 gauge wire, and the connections are pretty solid. I hope so, because we made sure of that in the other live stream. And yeah, the connections and everything was really good, and we have all of these CAN bus connections on all of these motor controllers as well. So this part, it's not gonna take that long. But yeah, the mundane part is over. We're in a much exciting stage of development. So I'm gonna pull out these screws, and we're gonna put them once we have made sure all the connections, all the motors are calibrated. Yep, so this one is in there. I'm gonna have to unscrew it before removing it. Let's try something different. I'm gonna bring in another L key. Yep, so it's a messy situation because, as you can see, all the screws we're using, all the tools, they're not even the same standard. So this L key is different. This is the first time I've had to use this L key for doing the same task, but because of the delay in material gathering, the different materials that we received, they're all different standard. So yeah, that's something that's gonna be an issue when opening and closing the actuators. It's not a really big issue, but I'm gonna try to find if we have the right we have the screws with the right keys lying around. So I'm gonna put it to a side now. Let's hope we don't have to use this L key ever again. I'm gonna put it back. I'm gonna turn this off. I am gonna remove these connections just for now. And let's try and attach all these tapes on these actuators, so we can write which actuators or which part of the body they go on. So I'm gonna write this on all of the actuators we have lying around. This is another one we're gonna be using, so I'm gonna attach one on this as well. So for the remaining ones, I think we'll have to change the wiring from 20 gauge to 24 gauge. It's not gonna take a long time, but yeah, we're gonna try to do it quickly. But yeah, it's something we'll have to do for sure. This one is also in a good state. We can we can try and move through this one quickly as well. When we have 5 of these, let's see if I can find another one. Yep, just yeah, this one is also usable. The goal is, if we have enough of these, that we don't have the motor controllers and the encoders soldered up, we can do that relatively quickly, as opposed to for the other actuators that I have already prepared. For those, we'll have to change the 20 gauge wiring for all of them, and we'll have to replace it with the 24 gauge wiring which we received later on in this series. So yeah, we're gonna have to do that sooner or later. Yep, I think that's gonna be it. For the remaining ones, we do have 20 gauge wire attached to them, and we'll have to replace that. So it's gonna be 1 2 3 4 5 6. Yep, 5 or 6 actuators. Yeah, so not that much. It's only gonna be like a half hour of soldering to change these 4 connections with the right ones. We're gonna be doing these today as well. I'm gonna put it to a side, and then I'm gonna grab one more of this this motor, and I think this one is cool. Let's attach a tape to on this motor as well. Now I'm gonna move all of them to a different table, so it's gonna take a while. And once we're gonna place them all on the table. We're gonna calibrate every single one of them one by one. We're gonna write where it goes on this tape over here, and then we're gonna solder the motor controller connections over here, and after that, I think we should be done with that relatively soon. And after that, we're gonna put together the upper part of the robot's body. Yeah, so excited for that. I am gonna start finding these hex stands, from the lab now. So I'm gonna be back in a second. So I found this, and yeah, I think we have enough. 3 6 9 and 12. Yeah, so there we have more than enough of these to hopefully put together the upper part of the robot's body. So what I'm gonna do now is, sorry for the noise, I am gonna go ahead and start putting a masking tape on these. So if I can bring the camera a little closer, if we can bring it down slightly. So yeah, I'm gonna start putting masking tape on these stands so they can easily go in these actuators. So we were using hot glue gun early on, and that process was a bit destructive. Well, it worked, but it was not the most efficient method of solving this issue. This way, I think hopefully everything will work nice and well, and even if we want to disassemble actuator for whatever reason in the future, we won't have any trouble. Someone else dropped a like on the video. Thank you so much for supporting the live stream. It does help with the algorithm. Like the live streams we did earlier that had more likes, they're still getting some views, like although the views are really insignificant compared to the other videos in the channel, but they're still getting views to this day. So yeah, it really does help in the algorithm. And some of the live streams we've done, they are at like 200 plus views, which is really crazy, because one of the live stream, it's like almost 4.5 hour long. So it's 4 hours 20 minutes. So it's a really long live stream, and it's still getting views every now and then. It's nothing crazy, but that live stream had a lot of engagement, a lot of likes on the stream. So that's why I think that's what we can deduce from that. Once we are done with building this robot, or once we ship this robot for the software, because we're not going to be working on the software for this robot, though I really would have wanted to work on the software part as well, but it's just the nature of the partnership we're in. We don't get to work on the software side for now, but I think we can, if this series does well, we can order all the parts, we can build this thing in a few days and explore the software side as well. But it all depends on how this series does, how well it does, and what direction generally this channel is headed into. But if you guys have any suggestions for a project we can work on after this humanoid robot, I would love to hear those suggestions as well, and we can consider building something else with the live stream format while documenting everything. And then once the live streams are done, of course with this project and whatever next project we'll do, I will be making a summarized playlist for all the steps we've covered so far in the live streams in the building process. Yep, so this attaching the masking tape onto these hex stands, it didn't take that long, as you can see, and it's gonna be the same with the little bit of soldering we have to do as well. So I'm really hopeful that we should be able to see the entire robot assembled together. So we're gonna be passing all the wires, the power cables, everything through the circuit breaker, and I'm gonna place it in line but before that we have to place all the power connections on the motor controllers, and we have to pass all that voltage and the ground wire through a common channel that's gonna lead all the way to this battery. So yeah, a little bit of soldering to do, but I'm feeling pretty optimistic about it. It's about 2 a.m. in the morning over here, and I think this live stream, just because we have all the components and everything ready, this can go really long, this live stream we're doing, and we also have to be somewhere tomorrow, but I think we're gonna push through, and we're gonna sacrifice a bit on the sleep side. If you have all the parts ready, if you have everything ready, you just gotta like sprint through it. It's because you have to come back later to just work on the same stuff. It's a good idea to just get it done with if you can. That's what we're gonna try to do today. So there's some residual tape on the top and bottom of these hex stands. It's gonna snug in there in its location hopefully, but the goal of this hex stand is to just grip the two parts of the actuator tightly together. So I'm not too concerned about that. I'm not too concerned about getting it perfectly aligned or anything like that, making the perfect cuts or anything like that, because it's not gonna hinder the motion of the humanoid robot in any way. If anything, if it snugs tightly in there, it's gonna help with the motion of the actuators, if anything. So yeah, it's a good idea to have it slightly longer than needed, but hopefully if you guys are ordering these parts, hopefully you just get the hex strands with the right external diameter the first time around. So we have 4 more to go. Ali, if you can double check after this how many 5010 and 6 M6C12 actuators we need for the upper part of the body, okay. Because I have separated 5 over here, the 5010 with this one. No, yeah, this is also the wrong one. 5, and then we have 6 more that we have the 20 gauge wire on. We're gonna have to replace wires for 6 more actuators. Yeah, actuators, the 5010 specifically, and then for the M6C12, of course, we can just attach the new motor controllers and encoders with them. It's not gonna be, yeah. We have a lot of these M6C12 ones. Thankfully we didn't solder them when we had the 20 gauge wire, because it's coming back to haunt us at this stage of the assembly. I'm gonna just finish the remaining 2, and then I'm gonna quickly grab some snack to sprint through the project. I think I was mentioning earlier how we will probably stay up way after 5 a.m. today, just to make sure. Yep. Yeah, we give it our best to put the upper part of the robot, upper body of the robot together.
That's a very real possibility.
Yeah, because it's like almost 2 a.m. in the morning over here, and yeah, with how it's going, there definitely is some repetitive process over here, especially with the naming the actuator, labeling them, and just to like, yeah, I forgot we need to give power to all of these actuators one by one to calibrate them.
Yeah.
Yeah, and
That's gonna be a problem.
yeah, that's gonna be a problem because all of them don't have these connectors on them, so we're gonna have to find some weird manual way of doing that. I'm just gonna be grabbing those connections by hand while calibration. Yep, so I'm done with all the hex stands, attaching tape to them. And how many do we have here? We have 3, 6, 9, 12. So we have 12 of them. How many actuators do we need for the upper part of the robot?
Let me see.
Yeah. So these are only the ones with the height of 10. I think we need the ones with the height of 15 for the M6E12. Though I'm not sure about that.
We need 10 for the upper body.
Okay, so things are looking good then.
Yeah.
Okay, I'm just gonna quickly grab snack, and it's gonna be like about 5-10 minutes, and then we're gonna continue with the assembly of the robot. Okay, so we're back now, and we need to start. We need to move fast, and we're gonna start with soldering everything together. And I'm gonna put this dinosaur away for now.
That was such a good dinner. I really need to eat.
If you can attach this solder over there. So what we are gonna do now is, in order to move fast, we are gonna quickly solder all the motor connections, like the connections for the motor windings with the motor controller, and connections for the power with all the controllers. There are only 10 controllers that we need to do this stuff for, and it's gonna be a relatively quick task to do that. I have a question. So we used hot glue for these actuators. Do we have to disassemble them
Yes.
and
Yes.
replace those parts?
Yes.
Okay, so
Also, I want to move over there because I want to flash the codes.
no. Before that, we are gonna work together on the soldering part.
All right.
So you're.
Let's just make it quick then.
Yep. We do have to move really fast with this
So
this part.
let me list down the parts for our ease.
So I think we need to. Let me see. Can you pass the water bottle? The
Yeah.
the bottle of water. The bottle of water.
Right arm.
Okay, so done with the water now, and yeah, I think I'm gonna have to make 10 wires for,
7.
so just to keep everything nice and coherent, we are gonna make these power connections using the black and white wires. So I'm only gonna pull out these cables, and let's see if we can get a solid length for 10 of these connections out of this, and then I'm just gonna move these to a
So
side.
for one of the upper arms, we need one MC612 actuator and 4 5010 actuators.
For one of the upper arm, once
Yes.
again, we need
One M6C12 actuator and 4 5010.
5010. Okay.
So
I think it would be a good idea to only get one arm ready.
yeah.
First of all, or I don't know. Maybe both of them together would.
I think one of them is good. One of them initially is good. There's just gonna be a lot of wiring and routing of all of the wiring.
Yeah.
Messy wiring.
It's gonna.
So let's just flash the codes, make sure all of that is correct, and just start the aluminium profile assembly part as well. Because
So
after that we can move in parallel as well. So
I think let's move this to a side for now, and also we're gonna move this to the side. Just everything, destroy everything. I'm gonna need a. Where's that really small 4-sided screwdriver that I just used to?
do we have more of these?
Nope.
So how it's gonna be a mess.
Yeah.
like
I think I'm gonna have to hold these wires with hand, or we can like tape them together with the wire tape, and then we're gonna Yeah, speaking of wire tape, the whole Hassan Abbey situation was really crazy, and
What happened?
yep. So afterwards, a lot of people have like studied his previous live streams, and they've uncovered some really damning evidence. So in especially in one of those shots, so his stated position right now, of course, is that he's uh, the collar he's using for his dog, it doesn't even have the ability to vibrate like at all, and that's the position he's sticking with even now. But a lot of people have uncovered one of his live stream in which the angle was slightly like from above the camera angle. So he has a bunch of cameras in his room, and in this one live stream, so exactly where the place where he reached out to grab before the dog yelped,
Yeah.
that location has the remote. It had the remote for the shock collar, and people, they looked up the exact variant of the model and everything, and that one, it has the ability to shock as well. And the funny thing is, he looked at the live stream, and he realized the remote was in there, so he just moved it out of the live stream, and then he looked at the cameras like oh shit, I've just been caught.
That's
So,
crazy.
yep. And his stated position, he's still like saying, guys, it does not have the ability to shock, and he's trying to cover everything up, and he hasn't even showed the exact color yet. So the way he showed it in his live stream was, he hid it with his fingers like this, and he was like, this is what the people are talking about, and he was hesitant to show the, while it's so easy to just show something like that you are on a live stream, but he was hiding it like this is what people are talking about. So yeah, the whole situation is really messed up. Ali, I think the way we're gonna start with this is, we're gonna start by replacing these two connections for this motor. Yes. So first, to make sure the direction is okay. So let's
Okay.
start with this one.
Right. All right. Let's just do that.
You
Bring it over here.
Be careful with the soldering iron wire connection. Okay. And let's remove both. It's not in the camera. I think it'll be a good idea to bring it somewhere where it's easy to see. Yeah, a little bit in there.
Be careful with the can wires.
Yep. Okay. It's
Alright,
still a bit difficult to see, but it'll do the job. Okay, so I have removed this one. Just let it be. Let it be. Let it
Okay.
like.
Okay.
And yeah, let's remove this one as well, and we're gonna. Okay, let's move it over here to this side.
All right. That's great. Now this one as well.
Perfect. I think it's solid. It's not gonna come off.
This one. Yeah, it's solid. So now we can remove this tape from here.
Yeah. The
Of course,
the solder iron connection it's like barely hanging on. So if you can bring that extension a bit closer, otherwise, yeah, I burned myself the other day, and you need to be really careful, especially when you're running with these things lying around if you're rushing your project. Yeah, so I think this connection is solid. Let me bring it closer. Let me give it the good old eye test. Yep, looks fine to me. And I think we can safely move this one to a side now. We just need to rewrite that the direction has indeed been fixed.
Yeah.
Where's the masking tape for this one?
I've removed it. I
So
just removed it now.
Just
Now let me just attach this new one. The direction is supposedly fixed.
I'll just write.
0 upper arm XR. 0 upper arm. Arm and XR.
We're just gonna start. I'm just gonna start pulling these out of my inventory. You know, like in games, you have an inventory.
It would be a good idea if I can just start laying these around on
But before that, we need to now make sure which order all these 3 wires go in. So let's make sure of that. So the windings.
The right one goes to the most inside one. Okay.
Okay, so the right.
The most top one, but we could be looking at both sides. I think it's very easy to just desolder and resolder if there's an issue. We'll just create a tag over here.
No, just let me make sure. Okay, this the bottom one. The bottom one, when it's facing the right, the bottom one is gonna go to the outermost side. Okay. Okay, I think
Remove these. Remove these.
These wires, or all 3 wires.
For now, we can keep it, I guess, because we want to test this again. But for every actuator, we'll need to insert the wires again.
Yeah, but
in the same one, because this is the right arm CAN USB. So all of the actuators on the right arm.
We'll do that afterwards. So just like, because this is the first one we need to test in the series, we're just gonna place it as it is.
Give it over here. So this is the right arm.
Okay, so before moving forward, we need one more of this big boy. Yep, so once again, let's make the motor connections first of all. And I am gonna bring this controller over here, and this one goes to this place, then like that. So let's try and put it over here.
Okay, which one are we doing? Which one is this?
We're doing this one.
Is it a 5010?
No, this is in 6 M6A12.
So this is for the left one then.
Yep,
Left
we
arm.
needed 2 of these, right?
Yeah.
We're gonna, right now we're gonna assemble for both right and left side, so we don't have to come back to soldering afterwards.
Alright.
Oh, before moving forward, I'm gonna have to cut a bunch of pieces from these wires so we can attach the voltage and the ground connections. So we have to set a suitable length. I think this much should be good. Yeah, it should be good enough, because the wire that is gonna be the common power and ground wire, it's gonna make its way to these wires, so we don't need these wires to be really long. We can have them short as well, so we don't want to waste too much wire. Okay,
Arm XL 1 upper arm YL 2 upper arm ZL.
so right now we are placing the motors we have gotten ready on a separate table, and we are labeling which motor goes where in the body of the robot, and we are getting the wiring and connections for all the motors ready. It's only gonna take, I would assume, 30 to 40 minutes,
Yeah.
and then we'll calibrate all the motors live on camera,
So-
and then we'll start putting together the
We will start the calibration and assembly in parallel. As soon as one shoulder is calibrated, just start assembling. and as soon as the next 5010 is calibrated, just put it in the front. We'll start assembly in parallel.
Yeah, we definitely needed some good camera angles today, but we're gonna make use of what we have available right now.
Zero
It's
upper
not a
arm
big
XL.
deal. We're gonna record a few videos once everything is ready. We're gonna record a few videos of the working robot. Just the assembled hardware. I don't know how much progress we will be able to make on the software side. So there is this tray that I'm looking for, which
What do you
has-
need?
Okay, so we cleaned up that tray, so yeah, I just need an empty tray for now. I'm just gonna use this one.
Okay.
So I'm gonna start exposing copper on these wires, and then I'm gonna start pasting them over here, and then we're gonna start with the connections. At least some of these actuators, they don't even have encoder on the magnet for the encoder on them, so we're gonna have to use the hot glue gun to put them in there as well.
Yep. So slightly irrelevant, slightly separate topic from the robotics field. I heard earlier there was a news that the Japanese government is banning international people or people from other countries from buying properties. So it's just
Interesting.
yeah. This year has been a year of one rule after another, one regulation after another. They seem to be getting tight overall around the world. US, Canada, in general. So the last 10, 15, 20 years have been the years of globalization, and now we're sort of seeing this reverse trend play out in almost all of the countries. So previously it was with the driving license situation in Japan. They are tightening some regulations in terms of that, but now it's with properties as well as in many other areas. So yeah, let's see how the situation unfolds.
I was in TIB looking at the Mars rover today, and they have added some really cool features in there. So
In the Mars rover.
yeah, the one, and I think that rover has been all around the world. So there's a international team, and a lot of student bodies have worked on the rover from all different parts of the world, and there are some really cool modules in there that I got to see today. And especially some of them were so precise, and they were about trying to find DNA samples and stuff like that, and microorganisms if there were any, and signals of life even in the dust particles or the sand or whatever part of ground the rover dug and gathered. The digging module itself was really cool to see how it worked, but even once the digging is done and if it has gathered the sample, they do run a bunch of tests on that sample on board and report the results for that. And it was really cool to see how everything worked. And
Yeah, that's pretty interesting. Research departments in universities here in Japan, they are working on pretty amazing projects.
okay, let's start putting this one together.
So I saw one actuator which a research team here in Japan built at a university, and it was a like 360-degree actuator. So one actuator had like a 360-degree motion, sort of like a, what's that, ball joint, a spherical ball joint.
Yeah, the one we have in our like shoulders and stuff.
Yeah. And that was a pretty interesting actuator to look at. I don't know exactly about the torque of it, how much torque it carried, but it was a pretty unique design.
Okay, let's start putting it together, and it is terribly out of the camera frame, but we're gonna make up for it
Yeah.
once we are putting together the arms of the robot.
Yeah. Chat, we're sorry for having the soldering part outside of the camera,
And
but
I'm gonna have to attach these two.
Yeah, we're really trying to sprint here and cover as much as we can in the couple of hours that we have.
I think you will have to let's just get these connections done first. So this one is gonna go over here, so I'm gonna need you to grab it this way. Let me try
Such a short connection, isn't it?
Yeah, but it's gonna be like everything is gonna be, yeah, it does not need that long of a wiring to begin with. I assume the motor controller is just gonna be dangling with the actuator once it's assembled, so no need to worry about the length, I think.
Yeah, I wonder in really practical projects or projects where there's a really high degree of precision required, I wonder how the length of the wire affects.
I mean, it has a really big, it has a huge effect.
Yeah, it does have a huge impact, but it would be interesting to see.
You know, like, especially if you're working on in microelectronics, the signal, even if it's just a power signal or a voltage signal, I think it drops significantly if the length of the wire increases. Okay, we need to now only attach the power cables over here, and just double check the ground is on this side, close to this arrow, right?
And just the below ground this arrow is close to the connection. This one.
Yeah. Okay. If that's what I thought. Just have it this way, and be careful with the solder wire. It might jump a bit because we do have to drop a lot of it over here. Yep, so we are almost done with one connection, so we only have to make 10 of these connections. If you can grab this wire, be careful, it's gonna get hot while I'm soldering. No, I want to apply a solder on the tip first.
Okay.
Like this, yeah. So it has something to latch onto on there. Put it in there. Yeah, way in there, yeah.
I think it's attached with this capacitor.
Grab this one.
Keep pulling it.
everything is happening off camera. I'm gonna try to fix the camera once we're done soldering this one. I'm gonna show you what we just soldered, and then I'm gonna try and fix the camera.
Yeah, let's just bring it a little bit over here.
I think we'll have to
I think this much
move
is good.
this display slightly out of the way, and then
Keep it here. We're gonna be needing this very soon.
yeah, but I think it's such a precise job. We
Okay.
need it to be close to us, as close to us as possible. Okay, let me attach this one now. Let me check it visually. I think I'm gonna have to check something using the DMM. And then why is it like short? Okay, let's try and see if the connection is okay. Yep, seems okay to me. And we just did it with one of the for one of the actuator, and we just have 9 more of these connections to go, and it's gonna be relatively quick. And then we're gonna calibrate all of them, and then we're gonna put together the body of the robot. So let's also move this to a side. This is the upper part of this actuator. Let's put them together like this. We're gonna calibrate, and then we're gonna write on this tape over here what part of the body it's gonna go in.
Yeah, so this one is for the left arm. I'm just gonna put this separately over here.
Okay, let's just cut these connections now, because we are gonna remove these connections. Or do we just grab another one? Why have we attached these on all of them?
I think we have it attached on as many as we could, and that's not a bad thing.
Yeah, it's not a bad thing, but do we have the
More? Yeah, we do not.
enough to go around? No, I don't think we will have to do hard soldering.
Yep.
Let's move it to a side for now. I'm gonna place it over here, and let's just deal with the ones that don't have it on them.
Okay.
So okay, once again, when we are looking at this way, I'm gonna bring in another one motor controller and actuator unit. Make sure all the wiring is okay and everything. And so yeah, let's put it on here, and I'm gonna
Make
I
these
mean,
to be connected.
you might let's just not keep it in contact with anything down below. You can just grab it in your hand, and it's the angle is really weird. Bring it up. Yeah.
Oh, okay.
And now let's try and attach over here as well.
It's really hot.
you want to keep this horizontal, otherwise it will reflow.
Okay.
Cut a little bit over here. Okay, now let's first attach the ground connection and the
VCC
and ground connection, and then we're gonna move on to the motor connection. I'm not attaching it. Yeah, I think it's a good idea to first add a little bit of solder on this. It gets way easier to solder them that way. I'm gonna do the same one with this wire.
We occasionally have some viewers joining the live stream, so guys, if you have any questions or want to know about the progress of the robot so far, or want to discuss any hardware or software project that you're working on, feel free to let us know in the comments.
Don't move it, don't move it.
Okay.
Hold it tightly in place. Okay, it's done. They have really cool solder sort of thing going on over here, so
Yep.
it's really easy to solder them on their locations and whatnot.
I wonder if a machine does this.
Yep, I think. No, I don't think. Most definitely, a machine does this. Yeah, grab it. Yeah. Another one done. We are moving on to the next one. Let's also put it on the side now.
Alright, I'll just label this for one of the arms.
I'm gonna pull out one more for the from the inventory. It's like an RPG game. Like I have so many of these soldered up and prepared.
Upper arm by
And we're gonna start working with this one now.
Alright, I'm gonna add this over here.
You know, before calibration, we're gonna have to attach, using a hot glue gun, we're gonna have to attach that the magnet for the encoder to all of them. Most of them, I think. Well, we do have one or two with the magnets already attached, but it's gonna take like 2 minutes in total. It's not. We can focus on that later on.
Another 5010, right?
Yep, we only have these ones left.
Okay.
We have two M6012 over there. Yeah, grab it. And let's try and attach the motor in the same breath. I think for how complicated this robot is overall, I think they have done a really solid job of documenting everything.
Yep.
You know, and we're just further breaking this down, especially with the soldering stuff on but it's really narrowed down to how you're gonna solder these things together. Otherwise, soldering is like a pretty basic skill, and I assume anyone who's building this robot would be really comfortable with soldering already. It's not horizontal. Okay, let me attach the ground real quick. And let's attach the yeah, thank God we don't have to change the 20 gauge wire with the 24 gauge wire yet. Otherwise it would have taken way longer to put everything together. We're done with another one, and let's quickly move this one to a side as well.
Yeah, I'll label this and move it to the side as well. 7 upper arm, Z axis and right. This is the right arm. 7 upper arm.
One more from the inventory, and yep. Yep, so good to have all this ready beforehand. So the live streams we did before, they were not in vain. It's really helping at this stage. Come on, grab this one.
I'll just grab this one. And in the meantime, I also have to check.
I wonder what the soldering nerds, what kind of stations they have where they're able to do soldering single-handedly in a really good manner.
Yeah, so it's nice to have a decent lab with all of the equipment. Really helps you pace up the progress on the projects.
Yep, it's solid. Let's turn this around and let's start working on the voltage and ground connections now.
Yeah, you can see in this image that they've placed it just like I did. Check here, left arm can, right arm can, so the 4 cans and then the actuators.
Yep. So they have taped all the.
I'm also taping and labeling all of them.
No, the motor controller. So they have taped.
Yep, they have taped it. It's a good idea.
Yeah, it's a good idea. So it does not like jump around. I want you to grab it from
the assembly might be a bit messy. We'll need to see how to route all of the wiring and how to make sure the motor encoders and the motor drivers, they're not just laying around on the robot, they're not hanging around from its body.
Are you talking about the wires or the motor controllers?
Both. So the wires we do not. I mean, initially
I don't think
they'll
that's a
be
big
hanging.
concern.
Yeah,
That yeah,
and motor
especially
drivers as
for
well.
the things that we have to deal with. Uh, right before the presentation, you can just use zip ties or anything like that.
So this one is also done.
Let me check it by. Yeah, I'm not too sure about this connection. I think I'm gonna have to move it slightly away from the. Yeah, it just came off the ground connection. I'm gonna have to resolder it as well. And then I want to move this a bit outside as well. So let's first try to fix this. Now let me try and pull it. It's solid. Let's try and move this one slightly outwards. Okay, I think that's much better. I don't think it's short with the resistor, but man, I really wish we had a better multimeter in our lab. I'm gonna place an order for a better one today because yeah, for now we just have to work with the one that we have. Yep, so just place it there as well. I'm gonna prepare the next one. So we have 4 more to go. And
8 lower arm X.
4 more of these. Bring in another one, and the connections, they also seem to be good on this one as well. Okay. Grab it.
Let's finish this one. After this, one arm will be done. This is the last one for one arm.
No, I think we have 4 ready.
We do have 4. This
The 5010.
This is the 4th one.
Then I must be missing one.
Yeah, this is the 4th.
Okay, just grab it. Okay, we are almost done with this one as well. We just have to attach power connections to this motor controller as well, and then I think we'll be done with.
Yeah,
So
just
just
the last,
rotate this around.
2 ones.
I was thinking we had 3 more to go after this, but I think it might be 4.
Yeah, 4.
Either way, we're almost done with this.
Yeah. The motor driver has become really hot.
Yep.
Soldering really heats up the drivers.
Yeah, but Okay, it's not concerning like at all. This much heat on the while soldering is totally normal. Is it okay? Like, let me try and view it once to make sure the connections are good and nothing is short in there. This ground wire, if pushed too much towards the side, it kind of interacts with this.
Let's just resolder it.
Yeah, we don't want it to do that. Don't move the board too much, okay? Okay, I think I've changed the direction of this wire now. Now it won't go there. Yep, I think it's good now.
Alright, this one also done. Let me label this and put it on the side.
Just put it on the side.
This one is 9 lower arm ZR.
So this is the last one without the thimbles or the connectors or whatever they're called. Then we're gonna have to cut those, and we might have to do a bit of work on this. So yeah, this one and this one, one of the CAN signal wire is messed up. We'll have to fix this before moving forward. Ali, I want you to grab this. First, we're gonna fix this CAN wire.
Okay.
Only this one. So now let's. Okay, let me go in there and try. I think it's perfect now. And now let's
solder the connection.
Yeah, first up for the windings of the motor. Yeah.
All right.
And let's do this first. And then this one. It's a good idea to have them all like hard soldered, these motor windings with the motor controllers, because I don't think if everything like goes well in terms of the direction of the motor, I don't think we'll ever have to desolder them again, for because it's just gonna be like sitting on the body of the robot, and there's no need to ever disconnect this actuator. I think on the power cable side, I think it would have been a good idea to have that those connectors to, if we need to troubleshoot a joint or something like that. It was a good, but I think we'll have to short everything, all the power wires, and cover them up using heat shrinking tubes, and it's irreversible. So when we'll give power to one of the actuator, it's gonna be transmitted to the entire arm of the robot. views are turning out to be good today, the total, but the average view duration is not the best. I think overall this project is coming to a close, like in a few days. I think we'll have moved on from this to some other exciting project in a few days, most certainly. Yep. Make it horizontal. We don't want this to flow towards the components, PCB. Yep, all good. Let me check it visually once and then we're gonna be done with this one as well. Yep, we're done with this. Yep, most certainly. Yeah, the components below on the bottom side, they tend to get really hot while soldering.
Yep.
While soldering these connections. Yep, so I think we are at a stage where we want to modify these connections a bit. Let's try and remove this. And this one as well. And then I'm gonna bring in one more from the inventory. So we have, man, I do hope we have enough in the inventory for the hand at least. So yep, we will. I no, this is totally the wrong size. Yep, so right now I am really looking for hopefully one more connection that is the right way around. Yep, thankfully we have enough in the inventory for the upper part of the robot. Yeah,
just put on a time lapse over here. It will be useful for the video later on.
Yeah. So yeah, we do have a magnet on here, and we need to cut these connections now, and we need to, while we're at it, can you look and tell me how many
5010s?
Yeah, we need
3 more.
3 more. Okay, so let's prepare them all at once.
Yeah, these 3 are absolutely necessary.
And let's put this over here as well.
Yeah, during assembly we can make use of these connectors if we need. At some maybe main power cable connections or some place.
Yep, maybe. So maybe we can just make we can put this on different limbs, like start of different limbs, like for example for the I'm gonna need a tweezer. Where's the tweezer?
It was lying somewhere over here.
Yeah, so we can attach it to the start of the limb section. So for example, at the shoulder, so we can cut power for an entire limb. But yeah, we can figure that out later on. No, it's not gonna be here. It's gonna be in one of those drawers. Sorry, here.
Yeah, it's here.
And I'm gonna cut these as well, and let's just prepare these wires one by one, and then I think we can move on to soldering the remaining three. I'm gonna put these over there as well, and I'm gonna apply a bit of solder to these wires so they are easy to attach on the motor controller, of course. And I'm going. So yeah, 3 more to go before we start calibrating these and we start assembling the upper part of the robot body.
I'm interested in the Berkeley Humanoid, but also in the K-Bot. I don't know if you know this robot, it's open source too. I think I'm assuming you are referring to the K-Scale Labs robot, if I'm not wrong. Yeah, I think that one is open source as well. Let me see. K-Scale Labs. K-Robot.
By the way, Reg, we looked at the figure 3 robot as well, and the trailer or the intro for the robot was really amazing. It seemed choreographed,
Yeah,
like
K-Bot.
everything, all the motions and everything were a bit too perfect. My initial impression were like it's definitely made in a CGI or some sort of a 3D software because it looked too good to be true. But if everything is real life, I'm really interested to see how their robot, like how it moves in actual real time, because a lot of those shots were in slow motion. What the robot moving around sounds like, and generally how it interacts with everyone, because I'm assuming the house the robot was moving in, it has been trained on that specific location.
Yeah, Reg, I have one question. When you say you're interested in the K-Bot, do you want to build it from scratch yourself, or do you want to buy it? Because its price is around $11,000. The last time I checked, its price is around $11,000. You get a fully built robot in that price, and of course it has an open source community around it as well, and you can upload policies to it, train it, and even contribute to the community, make unique and new features, code them up, and upload to a marketplace if there is one for it. But I'm assuming that by your interest in the keyboard, you mean purchasing it, because building it from scratch is gonna be a huge curve in its own regard. My take on the comparison between Berkeley Robot and KSK Labs one is that if you want, KSK Lab robot is closer to professional robots like Unitary and Tesla Optimus. It's closer towards that in a spectrum from very hobby or like personal project robot to fully commercial robot. It's in that gradient, it's more close towards the fully professional robot, whereas the UC Berkeley one is sort of a hobby project, as a prototype. And another obviously one of the main consideration is the price difference. Berkeley robot is around within $5,000. That one is $11,000. Figure 3 supports is supposed to be sold around 30k for the keyboard. I'm gonna build it because currently it's BO too much orders. Too many orders. Oh, I'm assuming so that's causing delays for them, that they already have too many orders in the pipeline. So you're gonna build it. Okay, that can be done. I'm assuming it's not gonna be totally different from the Berkeley Humanoid Robot. I have not looked into the keyboard specifically. Their open source community, their documentation, and all of that.
But yeah,
But it's not gonna be much different from
Yeah.
this one.
I think it's gonna be pretty simple and straightforward, especially if you're like working on a really flexible timeline as well.
Yeah, but on the whole, in terms of a more practical robot solution, KSK Labs one is definitely better than this one. This is more of a hobbyist or a really small scale prototype version of the robot if you just want to prove a few policies or show it to some investors maybe. But that one is more closer to the Berkeley. Is very cool, but yeah, it's a prototype. Yes, K-bot have too many orders already. I think the next, by the way, this was a surprise to me. I was honestly shocked to see the demand of the K-bot. I think they crossed $1 million in revenue within the first year of releasing their first robot batch. They already had too many orders, and I was not expecting people to show this much interest in an $11,000 robot. That really surprised me. For them, for its founder, it was also a shot in the dark. He was saying that he wanted to build a personal robot, so he sort of figured that other people or developers might also want to build a robot, so we're gonna solve this problem for them, give them a robot in their hands, to save their lead time in development, and just give it to them so that way they can they have an open source environment where they can contribute to it and make it do whatever they feel like, make unique versions of them, upload policies, so sort of create a community around it. And it's from what you mentioned that the next batch, it's in next years, as well as them getting so many orders and crossing this revenue mark. It was really surprising to me to see the demand. I was still thinking that robotics space is in general still a bit overhyped, and still it's not gonna make it to commercial markets very soon. It's just gonna be factories or just raising money with investors. Developers or common folks are still not gonna be interested in this, but their story totally stands against this assumption. Their robot is their overall their project and their vision has been quite successful so far. But yeah, that's pretty amazing to see that they have too many orders already, and I'm assuming they'll be pretty occupied ramping up the production at this point, which is a good problem to have. As for Berkeley, I'm interested to the motor because it's cheaper to build. Yeah, definitely. One good point about the Berkeley Humanoid Robot is that it is very cheap and affordable, and it's pretty straightforward as well. All of the 3D print files are very well documented and available. All of the BOM, the bills of materials, are very neatly written down. So yeah, it's cheaper as well as very straightforward to build. For the K-Bot, they built this robot in their father's garage, and a company approached them and they obtained $15 million funding. They bought their own house to continue their. Yeah. So the founder initially was building his own robot, and he was fascinated about building his own robot. And somewhere along the line, he just figured that if I am interested in this, other people might be. And yeah, I I think just like you mentioned, they obtained $15 million funding, but after that they spoke with many other investors and got much other funding as well. So they have a lot of investors, I think, and they have raised quite a good amount of money to continue on their venture. They're well set on their path to achieve their vision in terms of investment.
Can you grab this like in a horizontal?
The figure 3 demo was pretty amazing, especially in that demo they sort of showed the version where a robot is taking care of everything in the household, every mundane or boring task in the house.
Yeah, and towards the end, they also had a version for like for commercial use cases, like a receptionist robot.
Yeah.
So towards the end, they kind of hinted a few other markets they were targeting for their robot as well. And
Yes,
it was really interesting to see.
yeah, because everyone sort of has this vague or loose idea from the media in their head that robotics is going to be the next thing, and robots are going to be able to do mundane tasks in the household and all of that. They do have a sort of a loose idea. They just translated that idea in a well put together video, and that was really special about that video. It sort of showed that yes, it is happening right in front of us and it is possible. So not just for the figure 3 robot on its own, but it was huge for the whole robotic space in general. I think it really changed the way people look at the robotic space and robots doing mundane tasks or repetitive tasks in their house. That video did a lot for the entire robotic space in general. Are these connections done?
Yeah, I'm gonna have to test it.
This one took a minute.
Yeah, because I did it on single-handedly. That's why. There seems to be some weird shorting going on.
Short connections.
Yeah, but I'm not sure if it's supposed to be there or not already. Like, let me double check on this one, because a lot of times these connections. Yep, so there is a huge short connection issue in this one. So
Which one do we need to remove?
Yeah, this white one. So I'm just gonna remove it entirely, and then we're gonna resolder it. Let me just remove everything first of all, then we are gonna solder it closer to the edge this time, like this. And I'm gonna try and move this kind of solid, and let me check for any short connections now. All good now. Yep, you can place it to the other side now. We only have 2 more to go before we start calibrating all the actuators before moving on to the assembly.
I think that for figure 3 it must be programmed for the house where it will be. They will offer support at the beginning for each sale to learn the environment. For the slowness of the robot, it is intentional, because the problem when you sell in public is the risk of injury. Yep, true. They want to avoid that their robot hurts people. Yes, that's true.
Yep, that's true. And getting certifications for this robot, it's gonna be yep, it's a big challenge in itself, to because of the use cases of the robot. Like, it's gonna be covering so many tasks across the house. Getting those robots certified is gonna be a huge task in itself.
Yeah. So for the part where you mentioned it must be programmed for the house where it will be, I think it will be something similar to the Roomba, if you know about the cleaning robot.
Yeah, it's gonna be a really complicated version of Roomba.
Yeah, I don't know how. I don't know if it will be complicated as necessarily.
I mean, no. In terms of Roomba, it can just be a blind algorithm. Like, it just picks one direction and it just keeps moving in that direction until it runs in a wall. You can map the entire room.
Yes, same for the.
But the thing with that robot is, in the video it knew exactly where the dishwasher or the dishwashing soap or the deodorant for the clothes, everything, where everything was.
Yeah, so one thing is sure, that the CEO did say that it was not teleoperated.
Yeah,
that's one thing that we know from what he said. The other thing is that in the future, once these robots become a bit more commercially present and available, what might end up happening is that you have a robot that has this deep learning model with vision. So essentially a visual language model, VLM, and it's just gonna spend maybe a couple of days just roaming around the house at a very slow speed, and maybe failing a few times, falling down a few times, or identifying different portions of the house, the stairs, the walls, the bed, the different blankets, kitchen, drawers. Maybe it will just spend a couple of days just trying to understand the layout of the house, and then the next phase would be to just navigate around the house without doing anything. So without any basic, just navigating and making mistakes and adjusting based off on that. And maybe the next step after that would be grabbing the few things, opening up the drawers. So I think that could be one path of understanding, because every house is obviously going to be very different.
But the thing we can definitely bet on is once a few of these robots make their way in commercial houses,
Yeah.
like residential places and commercial places like receptionist roles, there's gonna be an explosion of businesses replicating that.
Yeah, it will get easier with time and with more houses. So it will sort of have a compounding effect, because all of the houses that it will learn about, it's the data is going to be sent back to a central server to retrain the deep learning model. And so with every house, it's going to become easier.
Yeah, so a lot of in big companies are just sitting on the sidelines. They're letting other companies or founders do the R&D and that sort of stuff. Especially really big companies, they don't like moving into these new ventures. For example, blockchain, for example, AI systems, and these humanoids, they just kind of let these small startups figure it out and then they try to acquire it. But once we have a few successful examples in a brand new field like the humanoid robot, we tend to see a explosion in that space. Generally a lot of bigger companies, they start acquiring those technologies. You start
Yes, sir.
seeing a lot of startups from places like China and other cheaper alternatives for those robots, and eventually that yeah. So right now what figure 3 and these companies are doing, they're kind of being the first companies they to innovate and
Yeah, so
commercialize this space.
I don't know if you noticed, but each hand in figure 3 has a camera in the palm of the hand. I think they use it to identify the objects and assess the proximity of the objects they want to grab. Yep. I would presume so, because for the commercial robots, very precise grabbing of the objects, so glass or blankets or bed sheets or just cleaning the room, that's a huge part of its functionality. Unlike the commercial robots or industrial, the ones that are working in warehouses, so their job is very specific to the task at hand.
I think it's gonna act something like it's gonna try to replicate the feel for in our hands and fingers. So for example, if it goes in like a really narrow space, it can have lidar or some sort of technology to observe how everything is placed together in there and what the things of interest are. Otherwise, we humans, when we have our hands in the really narrow spaces, we tend to feel things out to try to grab the correct one. I think I'll have to apply a lot of solder over here. I'm going to try and remove the wire now. Yep. We need more solder over here. And let's try and put it again. I think this one is done as well. I think I'm gonna have to test this with multimeter as well, just to be safe. But I think This one is good from the good old eye test.
Yeah, I think within one generation we went from having walkie talkies and not even having mobile phones to then having very basic Nokia mobile phones, the good old ones.
Yeah, then the Motorola's,
Yeah,
the
very old school
Blackberries.
mobile phones.
Yeah,
To
Blackberry.
iPhones, MacBooks, all of these technologies, to software, in the entire software domain, to then the AI, and now finally the robots within just one generation, and that's just mind-boggling at best.
Yep.
That's really crazy.
I mean, just compare that to how long the agriculture revolution lasted. Like, for how long we were in that phase only. Yeah, we stayed in that agriculture zone for like centuries.
Yep.
So, yep, this is the last one.
Okay.
Yeah, this is the last one we are gonna be dealing with before calibrating all the actuators for the upper part of the robot. I want you to grab this horizontally this way around. Okay, no, let's just make these connections first.
Yep.
Okay, let's see if we have any loose wires. We probably have a bunch of loose wires, but they're really far apart. I don't think it's gonna be an issue. We should be good to go. And last two wires before moving on. So we are gonna attach a VCC one and a ground wire for this. Yeah, so I think to calibrate all of these I'll just have to hold these wires in hand, or maybe we can use a electrical tape for it to make the power connections, because we don't want to solder everything right now before calibrating the motors. It's good that we have both arms of the robot ready.
Yeah, soldering.
Otherwise, soldering them again would have been a real pain. Let's try and let's see if we have any issues. We might have issues with this one, but the chances are slim. So let's verify it using this multimeter. It's raining outside right now as well. Yeah. The weather's been like gloomy for a while now, and it's also gotten really cold. I'm done with this one early as well. I think the next step for me is to grab the hot glue gun and attach the magnets to whatever actuators don't have them. We're gonna get a copyright strike. You know, I've heard a lot of YouTubers talk about getting copyright strike even while they're live streaming. So the algorithm for that is really, really good. Yeah. So this one has Ali. This one has magnet attached to it. So let's remove this wire now. The soldering wire, and I'm gonna attach all the magnets to the remaining actuators now.
Okay.
And you can start calibrating.
Alright, I'll just grab one by one and start calibrating.
So I think before that, I think we can adjust the camera slightly, and so even the computer screen is visible, something like this. And let me safely put this to the side. And I think good angle would be slightly, and if we push the computer screen down, some more of it is visible, a bit up like this. I think this is good enough.
Yeah, I think this is good enough.
And just place the actuators and everything over here. We have these over here as well. I am gonna grab this one, and we are gonna it has a lot of magnets in there, so I'm gonna warning, you're okay, don't mind that. I'm gonna attach these magnets to those actuators using a hot glue gun, and in parallel we are gonna be testing calibrating the actuators.
Yep. Alright, let's turn on the PC because we want to start the calibrating process as well now. Alright, so for the left arm we have 0, for upper arm XL we have it over here. First,
just put this one to a side over there.
Yeah, first of all we want to move with the right arm and finish all of its connections. So
I think we can figure out the CAN connections even after everything has been attached together. Though I'm not sure. If you can open up that picture from Discord, Ali, where they had all these actuators ready to be assembled, I want to look at what they did with the CAN bus connections, because those connections, they go from one motor to the controller to the next one. So I want to see exactly what's going on over there. Yep, so this one has no magnet.
you can check from here.
Okay, that's a bit strange. So what they've done right now, I think, is they've attached really long wires for the CAN cables, and it's not a good idea to do, because if we use really long wires we might risk losing these signals, but they haven't attached it anywhere yet. That's also an issue. They've also attached the power cables really beautifully and really nicely using connectors, but we won't have the time to do that, unfortunately.
Okay. 5. Can you show this?
So yeah, even when they have everything put together, the CAN wires are still dangling, so they're not even connected in the pictures I have seen so far. So which one do you need next? The 5010. I think it's a
No. So on the top line, the
Yeah.
most left one, which is the M6012.
Yeah, but we don't have a. Do we have a? Yeah, I think we had.
The magnet attached.
Yeah. So
Okay.
let me attach magnet to all the remaining ones so we can fasten the encoder on top. Um, can you grab from the same drawer? Can you grab the tweezer?
There isn't one over here.
Then it's gonna be lying over here somewhere probably.
Yeah, here it is.
And give me that one as well. Yeah. I'm gonna put together the magnet.
Alright, so for the right arm, first of all we have upper arm XR, which as you can see is this one.
It's not in the camera.
Here you go. So we have the upper arm XR first of all, which we're going to be calibrating, and the CAN ID for this is 2, which is very important. Can I grab a red color pencil from there?
Here you go.
So the CAN ID for this one is 2.
Yeah, and put that on the actuator as well.
Okay, over here. Now it's not necessary for the actuator. Anyways, we'll have different CAN USBs for different arms, so that comes later. Upper arm SR CAN ID 2. Now let's go to documents.
So I'm gonna place them. I'm gonna try and place them exactly where I grabbed them from. Okay.
Okay, for brand new board, SLL device, click accept and perform. Okay. Now we need to load the correct actuator parameters into the flash. The fields that need to be configured is also in the header file. First, configure the CAN ID according to this mapping, then scroll down and uncomment the corresponding motor type. Got it. Alright.
Okay, another
The
one
very
done.
first thing we're going to be doing is, first time boot up, we're going to be setting this to 1, so that way it defaults back. We're going to build this project. We're going to attach the connections to this motor driver. Just grab it from here. Attach the connections here. with that we are going to run this. Awesome, so that's step 1 done. After this, unplug and plug in again, then change the first time boot up flag back to 0. So let's just unplug this from here and plug it back again.
I'm almost done attaching all the magnets as well. After that, I'm just gonna attach encoders on top of the magnet, so everything is ready for calibration.
There's supposed to be a defined device CAN ID over here. Here it is, defined device CAN ID. In this case, we need it to be 2. Save this. The motor type in our case should be correct one. Yep, it's M6E12.
Yeah, we also need to attach the power cables with this.
Yeah.
The powering this one should be like really simple and straightforward because of the thimbles. But for the next ones, we're gonna have to find a hack.
Okay, yeah. In this one, load ID from flash to 0, load config from flash to 0, 0, 0. I think load calibration from flash. Yeah, also it's config.
I think I'm gonna attach encoders on all the motors now, just so the calibration process is straightforward and simple. And after that, I'll try and set up some method for us to get the power connections ready. They have like if we can scroll a bit backwards, they have these connectors for the power cable.
Yep.
Cables, but we're gonna be making hard connections. It's not a good idea, but that's what we have to do.
Yeah. Load config from flash 0. What about the calibration from flash? Okay, 0 as well. Save. So we have the CAN ID specified in here. We also have the right motor, and the parameters are also adjusted. With that, I think we are just gonna build and push this. Set it here. Okay.
I'm gonna need washers for this. Where do you know where the washers are? Yeah, sorry, yeah, just found them.
Okay, after this we just wanna disconnect this once again, reconnect it just to make sure that it is. Yeah, you can see this is blinking at roughly 1 Hertz. If it's now it should be visible, the camera. It's a very subtle LED over here, but it's blinking roughly at around 1 hertz. With that, let's see the next step. Okay. Alright, finally we are going to set this back to 1 once again, and we're gonna flash this for one last time. Okay, just save this and run this for one last time.
Yep, so done. In parallel, on this side I am attaching all the encoders and their magnets with these actuators, so they are ready to be calibrated one after the other. And these are the only 2 steps left before we can move on to assembling the upper part of the robot's body.
I would love to see this command running this time, because this time we have specified the correct CAN ID. So I will paste this.
Are you talking about the second
The
command?
calibration. This is for. No, it's not even the calibration. It's just a ping to the motor. I don't know if we necessarily need to turn the power on.
No, of course we need to turn the power on. If the motor is going to be moving at all, it needs the power.
I don't think it's gonna be moving. It's just a ping. Let's try this.
I mean, you can try it.
Yeah, there is some issue.
Grab the battery from there and try it again.
Can you plug this in?
Yes, this is the negative, and the positive one is it's going to be this one. You did not attach the can wire, Ali.
Do I need to?
Yeah, I mean it's. I think it's expecting something.
I hope so. This fixes the issue. Okay.
Yeah, just now it's working. Just try it again. So it's a different error this time.
Yeah, it's a different error this time. I think I would need to run this once again.
And I think in terminal you had to turn on the CAN bus.
Connection timed out.
What does that even mean? I don't know about these wires as well. Like they are all jumbled together. We don't want any of them to. They're probably, yeah, they're not short with each other, but we need to be like really careful with handling them. You can try turning it off and then turning it on again now. This the motor controller, and be careful with this connection. It was just dangling down below. Be careful with this. Another actuator done and ready for calibration.
I think there could be an issue with this. Anyways, I'll just remove these connections once. Have them back. Oh, this time it was successful. Motor is online. Perfect. So I just needed to disconnect and connect once again. Awesome, awesome, awesome. Alright, so this actuator is ready to be assembled.
I mean, we don't need to like run any, what do you call it?
Calibration?
Yeah.
We can try it. Let me.
Yeah, try with both of the codes. Another one done.
So our CAN ID is 2. Check this. Anti-clockwise first and then clockwise.
So the direction has been fixed. Perfect.
Yeah, what's most important this time
Yeah,
around
try the next one as well.
Yeah, what's most important this time around is that we have the correct CAN ID depending on the place of the actuator.
Okay, gotcha.
So this one has a CAN ID of 2.
Oh. Yep, so you see how it tries to rotate really fast and then it just stops.
Can you grab it?
Just give me a second. I'm gonna.
Yeah, it's most likely correct.
Okay, now.
Grab it.
No, now it's not even moving. And it's loose. Oh. It tries to do something. It tries and resets the position. Yep, so it won't let me move. I don't know what this issue is, but we're gonna be looking at it later down the line.
Alright, I'm just gonna remove the connections for this one, and this one is all good to go. However,
nothing you're doing is in the camera, by the way.
Yeah, we do need this CAN. So
yeah, just remove these connections. Yeah, just remove these connections.
Yeah, we'll just be removing these connections.
I got a screwdriver with two heads the other day. It's gonna be in that drawer.
What about these? Do we also remove these?
I think so. Yeah, I think we're gonna have to do this. Just let me attach all the encoders now, and then we'll sort out the power issue after this. We will have to test all of the motors, the anti-clockwise and the clockwise test. Why? Because we need to make sure all the voltage and ground connections are correct before putting the robot together. So we will have to provide power to all the actuators while we are calibrating them and when we're testing them. And yeah, we can do that using a double-sided tape. I have 4 more to go in terms of joining the encoder, and then yeah, so what I want you to do with these wires, Ali, cut these and expose copper on both of these, and by a lot of copper. So yeah, we're most definitely gonna be Yeah, it's kind of difficult to do, but we're gonna have to power on all the motors, and we will be hard soldering them together. Or you know what? We can just use a duct tape or an electrical.
We can just use a duct tape for now.
Yep, and even when putting the entire robot body together, we can use a duct tape, and once we are sure all the connections are good and okay, we can just use heat shrinking tubes on all the connections and make those connections solid. We're like already 4 hours in the live stream, and it's probably gonna be going for a while now.
Yeah.
Quite a ways to go, but we're pretty close. Pretty close.
I'm gonna grab this, pull it all off.
Yeah. Just remove everything and.
So this one is correct.
Yes, sir. I'm trying to keep the placement the right way around. Yes, but yeah, you can grab this one. Yeah.
Upper arm YR. 6 upper arm YR. Yep, that's the one that we need.
So
So first of all, I'm gonna have to check the CAN ID for this.
yeah, you
I'll go
can.
to the diagram. 6 upper arm YR. It has a CAN ID of 4. All right, CAN ID of 4. And with that, we wanna first of all, I'll just remove this for now. Yeah, so first of all we wanna flash the initial code inside of this.
What day is it? Today is Wednesday. Okay, Wednesday.
I'll also need to make these connections. The black one is the ground one.
What I want you to do with yeah, the can one. The black one is the ground one. Yeah. I don't expose too much,
Okay.
but I mean this. Yeah, this much should be okay.
Okay, and just alright, the black one goes to the ground. Ground. Steady ground.
What just happened?
The green one is CAN L.
Oh, so battery is getting low. Why? Yeah, so I haven't attached the charging. Damn, how? What a big mistake to make before live streaming.
Yellow one is can H. Okay, can H.
I'm gonna have to like adjust the camera. You are doing is visible in the camera, like, and it's been like this way for quite a while now.
Yeah, it's just a lot of repetitive work that I'm just doing. Just wiring and unwiring, wiring and unwiring. Anyway, so the CAN ID is 4. We can, with that information, we can head over to the software. Alright. First of all, the device CAN ID is 4 this time. Save this. First time boot up 1, of course. Save. This one is 5010-110. So 5010-110. There we go. I do have the first time boot up flag set to 1. Yeah, with that I can just flash the code. I'm gonna connect this. Connect this with the driver.
We are also gonna be testing, the counterclockwise and the clockwise calibration test with all of these. So
Yes.
I am gonna. You have not attached the CAN bus
We
connection.
don't need that right now.
Not even for the like counterclockwise and clockwise calibration test.
We need it then.
Like these, it's really scary the way these wires always get jumbled up.
Awesome. Upgrade was successful. So run. Let's go. So this was successful.
So where do we go from here? The next step is
No, then for the next one I'll just remove this, attach it once again, and first time boot up, set it back to 0, load ID from flash 0, load config from flash 0, load calibration from flag 0. I do have the correct BLDC motor. I do have the correct CAN ID. Just gonna save this and run this. This time there should be an LED blinking at 1 Hertz here. There we go. It might not be visible in the camera. It's a very small LED. But yeah, that's done. With that we can just set load ID from flash back to 1, load config from flash 1, load this one once again, remove this, connect it back once again. Make sure this time I'm also gonna make sure that the CAN USB is also connected.
are you like trying to power this motor up or not?
No, this time I'm just
Okay.
Okay, with that let's save this, run it again. Okay, so now we want to power on this.
The motor.
Yeah.
I mean,
Just a second.
hand me those wires. Those ones, yeah.
Okay. There you go. I'll just remove this once again.
Yep, remove all the connections.
Yeah.
Let's try and do this and do this.
Yeah, just this much is enough. Just this
Yep.
much is enough.
And for this one, let's try and do this and let's try and do this as well. Okay, so you are gonna grab both of these now for now, and then I'm gonna take them from you and you can start working on the code afterwards. So
Okay. Just grab hold of these. Put this again once more.
and you'll have to grab the motor by hand as well.
Yeah.
Or I can just do that. Okay, now I have my hand on the motor.
So if I do this, it's successful. That's a good thing. Now paste this. Our CAN ID is 4 this time. Let's see. Motor is online. Great. And yeah, let's test the motor. 4. Anti-clockwise first. And then clockwise again. Now it will be fun to see the other code.
Yep. The motion for this motor is very smooth compared to the bigger one, and that has been a constant theme.
Yeah, we've had.
Wow.
That's awesome. Let me grab a video of that.
With the controller as well. If I can just place it over here. Okay, just stop everything and then we're gonna safely remove the connections.
Okay, yeah.
First, let me remove these connections first.
Okay.
First of all.
Alright,
Okay.
I'll remove from here. I have to open these again. This actuator is also calibrated ready to be attached.
And let me open this one as well. And let me secure these tape wires. And yeah, so this one is ready to go.
So our live streams are just boring, repetitive work 99% of the time, with 1% cool videos like the one that we just had. Cool moments. But they're few and far in between. Most of it is just repetitive work. Yeah, this one is also ready.
I'm just exposing all the voltage and power wires to
Next one.
connect them with battery.
Here's the next one.
these solder connections just came off. I'm gonna have to heat up the soldering iron and redo it.
Can you pass on that red color? Is the yellow one, I will presume. It can etch. Yes, it is the yellow one. Can etch is the yellow one.
I am gonna be spinning up a message for the group chat, and I'll have you double check it, and then we're gonna send you.
Now, I don't think there's a need to mention this. So we're gonna be hard soldering.
Yeah, then we have to tell that.
Maybe.
No, because the software team, it's gonna be expecting all the limbs to be like detachable from the power and everything. We have to mention because of these reasons, everything is, and they cannot be taken apart. Like, what are you gonna do if, for example, you want to just separate out a limb? There is no way to separate the power.
Let's send a message afterwards, after the live stream. Alright, with this one, it's 7 upper arm ZR. Let's see. 7 upper arm ZR. This one has a CAN ID of 6. Once again, this is very important for us to know. Now we're gonna move to the software part. First time boot up flag. Of course, we wanna make it 1 for now. The motor is gonna be the same. It's 5010 actuator, BLDC motor. Okay, 1. First time boot up. Everything else stays the same. And yeah, we're just gonna make the connection and run this. Start calibrating this actuator as well. By the way, have you started getting a little bit tired?
Yeah, kind of.
Yeah, I think roughly 4 hour or four. Yeah, 4 hour is a pretty good estimate of a very, very.
No, I'd say tired isn't the right word for it. It's just like I'm thinking of how to make the connections because we don't have the connectors for the power one, and if hard soldering everything would be a right way to go about it or not.
Yeah,
It's
no,
just yeah, but I mean I can easily go for another 4 hours if we have everything ready for
yeah,
the
we can. We of course we can. Of course we can. But I believe there is this sprint time spent to the amount of work covered
yeah
graph, which sort of starts to decline after a time, and it's pretty natural for human beings.
yeah
And that's why when we see most of the live streams of people who are just studying or they're working or something, they use something similar to like Pomodoro technique, if you know.
yeah
So
I
like a
get
sprint
that.
for half an hour,
Yeah,
then
yeah,
a
yeah,
break
yeah.
and relaxation, and then a sprint,
Yeah.
and it just keeps them going for even 10-12 hours sometimes.
Yeah.
But consistently throughout these live streams, I've noticed that roughly around
Yeah,
4 hours is the time, is the mark.
I'm done with.
Okay, so with that, we're gonna set first time boot up back to 0. We wanna once again remove this connection, set it back up again, 0.
Yeah, we need to like sprint through these now because I've prepared everything in terms of encoder, connections, and exposing the copper for the power signal, so we don't have any issue.
I will just it's literally getting easier with every
Yeah,
one
yeah,
that I
yeah,
do.
yeah.
It is getting easier.
We just gotta sprint through it now.
Okay, 1 hertz, great. Now what we need to do is we need to set these back up to like 1 once again.
By the way, I'm really excited to see if the team we're gonna be sharing this hardware with if they're gonna be able to put everything together in a single day.
Yeah, same here, because we are really tight on the deadline regarding the milestones for this project. So
By the way, I think they should be able to do them because we are setting every single designation for the joint, the can. I think we'll have to solder the can connections as well. So it's just a plug and play.
yeah,
Everything is ready.
even then it's gonna be a challenge.
I don't think so. Like, yeah, I don't know. Maybe.
Guess we'll find out. Yeah. Whatever the sprint or the actual progress of the project is by the end of tomorrow or the day after, we'll know. We'll see where to go from there.
Yeah.
Load calibration from Flash. Okay, so I have set this back to. Man, I've forgotten. Yeah, so like first we want we set them to 0. Yeah, back to 1 and run it once again. This is the last run. Great. So this is also ready for testing. Let's just start the testing process.
Supplying it power.
Yeah.
So white is gonna be VCC, and let's give it 1 rotation.
Yeah.
And apply tape.
Yeah. Just
On
like
it.
this. We'll grab.
Yeah, I'll just keep grabbing it. Okay. And this one as well. We have to give it like 1 rotation at least,
Okay.
and then yep.
Just grab hold of these. I'll.
And this is. And be careful with the thimbles, don't like break them, otherwise it's gonna be really difficult getting them on again.
With this.
Just sprint through the testing process.
Yeah, so the CAN ID is 6, and we're gonna open up the terminal. First we're gonna set the CAN. Successful. Yeah, with CAN ID of 6. Motor should be online. Great. Okay, let's see.
Yeah, you can grab it. It's moving really slowly, right?
Yeah, that's how it's supposed to move.
No, but I think there's a bit of friction between the motor winding wires and the other.
It could be. Alright, so this one is correct.
Yeah, just move the next code as well, like the crazy rotation one. I think that one makes sure the encoder is. Yeah, this one makes sure the encoder is. Yeah, working fine.
No, it's not working fine. If you can grab it, it is hitting some part. Maybe this wire.
Yeah, in terms of like
Yeah, now it's fine. Now it's fine.
Yeah, that's what I was saying.
Okay. We'll add a flag to this. Just tape and add a flag to this.
Okay, remove it from here.
There.
Don't short. Be careful to not like get them short when.
Another one done.
Yep, and I'm gonna bring in the next one, and let's just quickly and
let me open this. It's a black, green, and the yellow in between. You can grab it now.
What's the next one we need?
Oh, I think I messed up the camera a little bit, and this should be fine now.
What's the next one we need? And where did I grab this one?
Okay, this was here.
I don't even know where I picked this one from.
Just place it over here. Okay, so 1, 2, 3 are done. This is the next one. 8 lower arm.
Yep, let's hurry through this. Let's hurry because we have the other arm, the entire.
I will set up the code. Can you make these connections real quick?
Which connections? Okay, yeah. Give me the plier.
And the over there.
No, this is not the right one. It was supposed to be green in color.
I don't have a green one. I'm just.
I mean, there's supposed to be a green one over here. That was a perfect match for. Okay, let's just move on with this one now.
Is this a plus or minus?
Yes,
this is a minus one. Okay, I will check the wiring. 7, 8 lower arm XR. So this one has a CAN ID of 8.
Oh my god. I also need these here.
Yep. This one has a CAN ID of 8 and it is the same motor. So CAN ID is 8. First time boot up, we will set it to 1 for now. Everything else is just 1 and the motor is correct.
Just double check for me for now if the yellow one is CAN L or CAN H.
Yes, so the yellow one goes in the middle.
Okay.
I'm sure. You just put the black one in the ground. Yeah, black one in the ground.
The yellow one is
Can H. It's can H.
okay. So now it's gonna be easier the next time around. Yep, so I'm ready on my side with the connections. You can just plug the wire,
Just remove this.
the USB cable.
Can we not remove? Oh, like this. Okay. Just plug this in for now. For now, we do not need to plug in the can. You can.
I mean, just
do it.
put it in there, like while we're at it. Why not?
Okay. Alright.
Meanwhile, I am gonna be attaching the power cable connections as well. The camera is, the angle is once again messed up. We can't see this. Why are we not able to see this though? It's like really high up. Okay, yep. Okay, so you have to like upgrade it
Every time.
every time.
Yeah.
That's so
Alright,
annoying.
Now I'm gonna run this.
That is annoying.
Alright. That was the first time. I'm just gonna remove this. Insert it once again. First time boot up 0, this time 0, 0, 0, and save it and run once again.
So
There we go. Alright, and yeah, it's perfect. Now remove it once again, connect it once again, and I'm just gonna flash a code one last time, after which we can start the calibration. Run. So this one has a CAN ID of 8. Okay, great. After this, we will remove this once again, this one as well, back in, and you can make the connections now.
for the power,
Yes.
yep, they're good now. You can just
Okay.
leave them.
Now, first of all,
I
we
have
will
this
use
motor in my hand.
After sudo IP link, we wanna ping the motor.
8.
It's online. Okay. After pinging the motor, we wanna do the calibration. Check.
Okay, it's perfect.
Right.
And the next code as well, real quick.
Yeah, I think that one is not really that
Okay.
important, but okay, we can.
Yeah, I mean it's a good idea to just
Yeah.
go through, burn through it, because it just takes a second. Don't get it short because that side is plugged in.
Let's move these.
Okay, I'm gonna bring in the next one. I mean,
I think the next one is the last one for one arm, right?
Yeah, but we need to have both of them prepared because this is quite a repetitive process and we don't want to go through it again. What are you waiting for?
9 lower arm ZR. 9 lower arm ZR is 10. Alright, let me write 10 over here. First one boot up 1. The motor is okay. Yeah, I think we can start making the connections.
The yellow one goes in the middle, right?
Yep. I will just flash the initial code.
Yeah, like go through the entire process. We don't need the CAN connections for the first few steps.
Open in update mode. Upgrade.
We have 5 more to go after this. Yep, this is officially our longest live stream yet, and I think we'll be going for about 1 to 2 more hours yet. What?
Huh? What? It seems to have an error in the final. I think we need to make the CAN connection. Let's see if that fixes the problem. Alright, so for the final flash we do need the CAN connection.
Well, that's helpful. So now next up is the
Yeah,
power.
yeah.
Just detach power from that side, and then we're gonna. Okay, now let's make sure these connections are good. Let's power it up. Okay, it's powered up from this side.
After this, instead of picking the MC612 actuator, just grab the 5010s, because I would need to change the motor for that from 6012.
Oh yeah,
We'll do that
yeah.
in the end.
Okay, makes sense. Yeah.
Okay.
Okay. Yeah. This one is good to go. Just like remove all the connections and stuff. Also the CAN ones. Just disconnect the CAN from there. Okay, so next up I am grabbing this motor, the one right next to the 6012. So the first one. Okay.
This one was 10. Okay, so now we have moved on to the left arm. For the left arm, first of all we have of course the MC612. After that we have the upper arm YL. Yes, it's upper arm YL. This one has a CAN ID of 3. Alright, I'll start preparing the code and just I'll start flashing the up till the point where we need the CAN connections as well. First time boot up, of course 1. This time the CAN ID is 3. Save this. I'm gonna make the connections to the driver. And there we go. I'm going to flash the code. This is a really strange problem that we've just run into.
What?
I hope everything is just... yeah, everything seems to be correct. So...
what's the issue?
no ST link detected.
That's really strange. I think you can just disconnect and retry.
Yeah, probably.
Maybe we need to... no, I don't think we need to do that.
Oh, yep. Just disconnecting and reconnecting somehow fixes everything for these motor drivers.
Thank God, man. At this stage it would have been really messed up to have that issue.
By the way, for the guys watching, have you guys ever sprinted on a project for this long a time consistently, these many hours? It's certainly not the first time in our case. We have sprinted on projects like this before as well. 0 load from flash 0.
So in today's live stream we have moved from setting up the environment in this brand new PC we got today to a little bit we did a little bit of soldering, a little bit of attaching motor controllers and encoders, and now we are well on our way through the calibrating almost all the actuators for the upper part of the robot's
this
body.
one consistently seems to run into an error. I'll try attaching this. Oh yeah, that could be the cause.
Just remove that.
I'll just remove both of these once again. Then let's have them both back on. I think this one does this one have some issue with the soldering connections of CAN wires or some other soldering connections?
No, I don't think so. Like none of. I don't see any visible issue with the soldering connections. Yeah, maybe this ground and these wires are really close together, but I don't know if they are short. I'm pretty sure I made sure they were not short.
Yeah,
We'll have to double check with the multimeter then.
Alright,
You can
I'll
grab
just
it.
remove all the connections and
Yeah, just remove the connections and everything. And
where's the multimeter?
there.
This one has been giving error since the start.
I don't think these two are short. I don't think this one is short, and definitely this one is not short. It's the same for the CAN bus connections, and I'll have to double check the CAN connections. The CAN connections are also fine, totally fine. And VCC and ground, we haven't even attached them yet. I think you can try turning this off, and yeah, let's try and go through it all over again. Otherwise we'll have to change this motor controller perhaps.
This one is very strange. Same issue.
Error finishing flash operation.
I would say just put it on the side and bring in the next one while we're sprinting through these.
Okay.
Yeah, I'll just highlight this, that this one is causing problems. I'll remove the CAN connections.
Yeah, I don't know what's wrong with this motor controller.
So the next one would be for the left arm. The next
Yeah,
one
this
is
one is joined firmly. Can we test it like this? Yeah, there shouldn't be any issue testing it like this.
Yeah.
So just like, let's put everything together for this one.
Alright, so this one has a device CAN ID of 5, first time boot up 1. Initially these are 1, we do not want to turn these to 0. Okay, save, and yeah, let's just connect this one and start flashing code to this.
What?
No device found on target. I think it's just a standard disconnecting, reconnecting. Alright, okay. What's this?
I think it's kind of good in a sense that we won't have to mess around with the soldering bit. We just have to look through this. Yep, it's the exact same.
Connection timed out. Why?
I think we should turn off all this software as well. Did you try? Yeah. and just exit the terminal and everything.
No, we don't want to exit.
Yeah, I mean, yeah, the terminal. Yeah, terminal should be fine. Maybe it was just some sort of timeout issue for the ST link.
Yeah, so like disconnect this, reconnect this once again.
Yep, it fixed the issue. Now let's move on as fast as we can.
Alright, I would need the CAN connection, I think this time.
Yep, it's ready. You can just plug it in.
File, save, remove this, add this, and run it for one last time. With this, I'm just gonna send a ping. First of all, IP link. Yeah, it's successful. We wanna send the ping now.
Yeah.
This one is 5.
So do we need disconnect and reconnect, or we can just you can try.
Motor is on 9.
Yeah, just send the command.
Check the motor if it's moving anti-clockwise.
Yep, it's moving anti-clockwise, and now it's moving clockwise.
Great. Just this one is also good.
Yeah, this one is perfect. Let's just turn off everything.
Yeah. This off.
Okay, let's remove these connections. Remove it from there. I'm gonna unscrew this.
I'll prepare the next one. This one was 5.
This
Successful.
we don't have labels on the next one.
Don't worry.
No, how are you gonna make sure this is the?
Just bring one and we'll label it the next one.
I mean, you haven't labeled this one.
It's fine.
How are you gonna know which one this is? Like
We can label it right now to be the next
See,
one. Just give.
we just tested this right now.
Oh, we just tested
Yeah,
this? Okay,
yeah.
I'll label it according to this.
Yeah, label it. And we're gonna have to label the next ones as well.
Yeah, give me the scissors.
What?
Scissor.
Give me the duct tape.
Okay, so this one was 2 upper arm. 2 upper arm. Okay. Place it over there.
Label it before we start the test.
3 lower arm. 3 lower arm XL, and I'm just gonna
Yeah.
check.
Kudos to anyone who's still watching the live stream.
3
This
lower
is
arm
our
XL.
third last actuator that we are calibrating right now, and
And
the stage right after this is the assembly of the limbs of the robot, especially the arms. We're not gonna be working on the lower body of the robot for now. We're only gonna be dealing with the upper body of the robot.
awesome. So remove this. Connect this back again. First time boot up 0. Load ID 0. Load flash 0. Calibration 0. Save this code and run it once again. Alright, and now for the final ID from flash 1, config from flash 1, and calibration 1. Safety watchdog is enabled. We have the device can ID 7, which is the one that we need. 7. Alright, yeah, let's just upload this final one. Do we have the CAN connections?
Yeah, the CAN connections are ready, and the power connections are almost ready as
Yeah.
well.
I think we only need the CAN connections for this final upload.
I mean, of course, after this we're gonna.
Yeah, we're gonna be needing the motor. Okay, done. Awesome. We can now move on to the calibration.
Yep. So attach these. Just grab these ones. Okay.
From here, just reconnect these once again.
Yeah. So the wires for this one are all over the place. They are a mess. Honestly, it's gonna be surprising if this even moves. The wires are all over the place. And it's moving.
Is it? And yeah, it's anti-clockwise.
Yeah, it's really surprising.
Awesome.
But yeah, another one done. Let's just remove all the connections real quick.
Yep.
And we just have one, two, three more to make sure. So first up, label this one as well.
So this one is 4 lower arm ZL. It's labeled.
You know, we have to make a solid power connection, solid kind of power connection for all the wires after this.
Awesome. With that, I set this back to 0 once again. 1 to 0, 1 to 0, finally 1 to 0.
I so wanna
No
grab a
calibration
coffee.
Flash. So you can watch together. No, you don't want to do that.
No, not right now. Like from that cafe up on the hill in Futako Tamagawa right now. I mean, imagine if that cafe were 24/7 and the weather it's really nice. So yeah, a lot of people would be going there at this time if it were 24/7. I'm just murmuring at this point.
Like half of our brain cells are asleep at this point.
Yep.
The other half are really pushing through.
Yeah,
Trying.
they're trying really hard to not make a mess of this wiring.
Alright, we are ready to start testing.
Yeah,
We'll just remove these ones.
just attach these connections. And it's really interesting that the only thing really that really kept us from testing these actuators, calibrating them and putting together, assembling the body of the robot was actually the PC. Yeah, that was the issue all along.
Anti-clockwise, so it's correct.
And we have another motor working.
Yeah, bring in the one that was not working. Let's first of all deal with
Yeah,
that,
yeah,
and then
yeah.
we'll just deal with the final one.
And the crazy thing is, none of the people in the Discord are sprinting or rushing through this project like us. It's, I think after putting together the upper part of the body, or especially,
I think we can call it a day after all the calibration is complete. However, we can continue working on the assembly, but for the live stream part, because we'll be very focused on the assembly.
yeah, I think assembling it in front of the camera,
All right.
it'll be a good idea. It'll make for good content for the later part of the video production.
Yeah.
But you know what I was thinking? I was thinking we should call it done after delivering the upper part of the robot's body. Where's the screw, man?
So this was a 3. It was not working, right? It was a 3 one.
I think so.
Yeah. Let me see if this works. One upper arm
So
YL is 3. Yeah.
yeah, so there is one issue that I think was occurring at that time. Let's see if it works this time around, and that issue is probably gonna be it. I think the VCC and the ground wires were short, and that is what was causing the communication issue between the motor controller and the PC. Yep, so I think that was
Still the same issue.
it's still. Can you try turning off everything and then
Alright, let's try that.
it's probably not gonna work, but what's the other option after this for us then? Yeah, I think it's gonna be an issue. Can you are you on the very first step with this motor controller, or is it like a later step? Maybe you can try assigning it a device ID and everything all over again.
I have already assigned it the ID.
No, like try assigning try going through those steps again. I was saying try instead of try. I'm that tired right now.
Same issue. Just put this aside and bring in the M6C12 one. We cannot enter a debugging session right now.
Yeah, I mean we cannot for sure.
I think once all of these are connected and the body is assembled, the upper body, still they can be attached and calibrated. It will just be the arm moving, but they can still be calibrated.
Yeah, I think so. Yeah. Okay, let me bring in the next one.
Bring in the final one. I'll make preparations for that one. So the motor is different this time.
I'm just gonna place it totally to a side now.
And the ID for 0 upper arm XL, which is 1. Okay. The ID for this one is CAN ID of 1. Save this one. Okay.
Tomorrow we'll have another Venture Cafe event here in Tokyo.
Yeah, most likely. Oh, of course we won't be going. We have somewhere else to be at tomorrow.
Yep. Oh yeah.
And that too for a very long time.
Yep. So we're gonna leave that place at I think like 8:30 or 9. So this motor is placed upside down, but let's try and rotate it without. Let's hope nothing got short circuited over here, because the wires are all over the place. Why has the
Not, yeah.
the video stopped?
Which video? Huh?
Hmm.
Is there any issue with the OBS or the phone?
Okay.
Let's see.
Ah, damn. Yeah, the charging wise, my phone is done. It is working somehow, barely, but I think the charging is gonna run out. Let's just turn off the live stream then.
Yeah.
Guys, really sorry, the battery for the camera that we are using to record everything, it's about to run out. We're almost at the assembly stage of the robot, and we're gonna be proceeding and putting together the robot. And I am gonna try and record everything, and maybe we'll do a live stream of that recording, or maybe I'll just upload a YouTube video of putting everything together. But yeah, this camera will turn off at any moment, so unfortunately we'll have to stop the live stream over here. But thank you so much for watching. This has been our longest live stream yet, and I'll keep you guys posted on the progress, and I will record I'll take a picture of when the upper body of the robot is assembled together, and I'll upload a video as well of the upper body of the robot assembled together. Thank you so much for always supporting the stream, Reg. It's always so nice having you around here and having your little avatar walking around. So yeah, I'm gonna turn it off now. Thank you so much again, guys. Thank you, Reg.
Thank you very much.